All range personnel be advised, rocket discharges are armed. GSE, confirm ground side status.
GSE is locked.
Flight ops status check. Return go or no go for launch.
Fido is go.
OSM is go.
OSO range is green.
Go flight.
All flight and range ops are go, locking in for terminal count.
Okay. Okay. Hello? Hello? Are we there? Do we have acquisition of signal? AOS. Type AOS if you're hearing Joey B right now. There we go. Okay. Hello everyone. Welcome to the live stream. I don't know what happened. I even did several test runs of the live stream too to make sure that the microphone sounded good, and it just stopped working. Okay, anyway, so here we are. We're in the rocket factory, aka my apartment, and we're going to be building the ARC flight computer. Now, ARC is what's called, it's different than Signal, so this is Signal right here. And ARC, go over here, is what's commonly known as a dual deploy computer. So what that means is you put it inside a higher power rocket and you use it to deploy two different pyro charges, at least two. Two different pyro charges on your rocket to separate either a drogue parachute or a main parachute, something like that. So it's a lot smaller than Signal too, but it has a lot of the same components. It just functions at a much smaller scale. So this is Signal, and this is ARC. So ARC is like a cute little baby version of Signal. It's got a lot of the same branding. It looks kind of similar too. I have fruit flies in my apartment. Yeah, it looks kind of similar. Everything is really crammed in there on the PCB. I mean, there is no extra space. Signal, you can see, is like a little bit more spaced out and where the components are, but Arc is really just totally smushed. So anyway, yeah, if you have questions, if you're new to the live stream, welcome, thanks for joining. If you're not new, I'm going to say this, but you know it already. If you have questions, you can put them in the chat. I'm going to try to answer them as I go through. We're going to be assembling all of the components that go on this computer today. So there's a bunch of them. I think there are like, I would guess like 70. No, that can't be right. That's got to be too high. There's a lot of components that go on this board. I have to unpack the DigiKey box, and that's where all the components sort of exist. And so we're just going to go ahead and get started. I'm going to move over to the workbench view here. And there we go. Okay. Also, as is tradition on the Joey B live stream, I've got a cup of tea here. Oh, look, you can even see in the tea. So this is salted caramel tea by Bigelow. And it's black tea, but it's got like a salted caramel flavor. It's super good. And that's what's up. Okay. Can I post this live stream to my channel afterwards? Yes, I can. I actually switched. So I used to do live streams on Twitch, and now I do them on YouTube because YouTube will store them afterwards, like indefinitely. Okay, so here we go. We're going to be building 3 of the Arc boards. Let me zoom in here. Okay, that looks pretty good. 3 of the Arc boards. And then there's another board that goes along with Arc. And this one's just for me. This is called the Piggy board. And the Piggy board piggybacks onto the back of Arc. So Arc has these little test pads all over it that transmit signal from the Piggy board to Arc so that you can program it, or that really so that I can program it. And it helps save weight, it helps save complexity on the board, it helps a lot of routing stuff so that as the user you don't have to like have a USB port and never use it. All of the stuff that happens on Arc is configured through Bluetooth or through the SD card that goes on the back. So programming ports are just not needed, and so we have these little test pads that the Piggy board can talk to Arc through. Okay, so we're building these 3 boards. I want you to put in the chat which one you'd like to build first. We can either build the Piggy board first. Piggy board is super simple, like 2 different components. We can build the Piggy board first, or we can build Arc. And if you have an opinion, if you think you know the right answer, there's no right answer. But yeah, here we go. One person says Arc. Erfan says Pig. It's the Piggy board. It's not just Pig. Okay, I'm gonna read some chat here for a second. Okay, don't put the Piggy board upside down this time. Yeah, you remember that. I did that for sure. Okay, if you're using dual deploy computer, does that mean there is a level 2 or 3 cert in the future? Yes, sir, or ma'am. I actually don't know what gender you are. Yes, the answer is yes. I would like to do some higher power certification stuff because I would like to build some higher power rockets. And this is a great opportunity to help plug the Patreon account, which just got a big old update for BPS. If any of you have seen the new video on the channel, we talk about how to land a model rocket. There's a whole series coming. There is a whopping 22-minute video all about flight simulation and motor choices for landing a model rocket. It's out now, and if you want access to it, you can get access through the Patreon. It will be out publicly late next week. So that's the Patreon, and the Patreon helps fund things like higher power certification, development for these type of boards, things like that. Okay, so that was a long answer. There was a tornado coming to my house, RIP. Rip in peace. Okay, looks like Piggy board for the most part. Is this for landing your rocket? No, this is not. This is just a dual deploy flight computer. Okay, Piggy board, Piggy board, Piggy board. It's definitely going to be the Piggy board. So that's what we're going to build first. Let me move these guys out of the way. And the Piggy board is real easy. I have a whole box of components here. We don't need this, but I am going to have to do a little bit of stuff here. Okay, we don't need this. So the Piggy board needs these guys, which are, you can see them better that way. These are the terminal blocks for the Piggy board. And then it needs one other thing, it needs the test pins. Oh, and it needs a USB port and a reset button. It actually needs 4 components. Okay, unboxing with Joey B. Hey guys, welcome back to Unboxing with Joey B. Today we're unboxing a DigiKey order. I paid a bunch of money for all of these components. They all come in little blue bags. DigiKey does a great job packaging them. Thanks for watching Unboxing with Joey B. Please tune in next time. Don't forget to rate, comment, subscribe, and catch you guys in the next one. Peace. How'd I do? Okay, that's a capacitor. These are servo pins. I shouldn't have servo pins. None of these things have servo. Oh, that's for the impulse board. Oh yeah, we have one other board that we could build tonight too if we have time, which is the impulse launch computer. But that one's not as exciting, and I've pretty much built that before. Okay, resistor. These are all garbage. I mean, they're not garbage. They're just like not useful right now. Here it is, test pins. Okay, has anyone ever seen these? These are super, super cool. Okay, so I'm gonna zoom in on what they look like. So these are spring-loaded pins, and basically the way they work is one side gets soldered to one board, and then this top part here can compress so that it stays connected to the board that it's connecting to. So this is how the Piggy board talks to ARC. Isn't that cool? I think that's really cool. I'm gonna zoom back out here, make sure we're in focus. Okay, memes are go. What's going on, chat? Hey, it's Chase. What up, Chase? Hola. Can you describe the different parts and how they are hooked up on the board? Yes, I can. We'll get into that later. Even in Korean. Soldering. Oh my God. Yeah, hold on. Can we back up a little bit, everybody? So, Brian Souza asked a great question here, which is the sole purpose of this dual deployment? And the answer is no. So, my goodness, it's so small I have to like zoom in. Okay, here we go. Looking good. Okay, so this is ARC, everyone. This is ARC. So I have to get out some tweezers because it's so tiny. All right, let's walk through. This is actually kind of what Weatherworld asked here, which is, can you go through the components and describe what they do? And again, the answer is yes. Okay, so in the middle here, we have a processor. This is the thing that's going to do all the math on board. It's going to do a couple of calculations, things like that. If we move right above, there's an LED that's going to go right here. It's a little red, green, blue LED. It's the same one that you've seen on the signal boards. This is a Bluetooth chip, so this is how you can talk to the computer with your phone. On your right, in the middle, it's hard to orient this, on your right, this is a flash memory chip, so this is the start of all the cool stuff, which is data logging. So all of the data logging stuff that I had to build for Signal ports really easy over to this board. So it's going to be 40 hertz of like 30 channels of data, and they all go into the flash chip during flight. Okay, and those channels are data. So we have a barometric altimeter here. This is a pressure sensor that goes right there. And then this is an inertial measurement unit, so an IMU. Now you can't actually actively control your flight, like you can do with Signal here, but you can use the IMU to get a lot of data back. You can get acceleration data, orientation data, some vibration stuff, I guess, if you like look at the acceleration. Okay, cool. So these are the main sensors here. Once again, we've got a barometric pressure sensor. There's a Bluetooth chip. There's a LED. There's a flash memory chip, and there's an IMU. Here's our processor again. There's some crystal like timing stuff here. This is just like pretty typical things. We've got a 3.3 volt regulator here, and then a power switch down here. Now, here's the thing about high power rockets. You ready? This is rule number one with high power rockets. The thing is, you don't want to have to like open your rocket. So it's a little different for me to build like a tiny rocket, you know, out of this cardboard tubing, and I can easily just like open it up and then modify things, or like I fly all of my rockets with a big hole in the side so I can like access the flight computer. But with a high power rocket, you want very low drag, so you don't want holes in the side of your vehicle, and you just don't want to like, okay, well the rule number one, you don't want to have to like open your rocket. Anyway, so a lot of people put holes in this, they put like switches embedded into their rocket, or they have a magnetic switch that's through the wall. Anyway, but people have different preferences on how this works. So this switch here, this power switch, you can use it if you want, but it can also be bypassed with a terminal block that's going to go right here. So this S thing here stands for switch, and if you just connect two leads up here and connect a switch to it, you can turn the computer on and off externally. Here we go. P1 and P2. That's Pyro 1, Pyro 2. These are super configurable channels in terms of like time delays. You can fire them at different events. You can fire them based on altitude during ascent or descent. There's all sorts of stuff. And then a battery input. Now we'll flip it over. And okay, so here's the SD card. That's where this goes. Now the SD card is not good to be writing to during flight. This is why we have a separate flash chip. But when the rocket lands on the ground, the flash and the SD card are gonna talk to each other basically, and the flash chip is gonna send all of the data that it recorded in flight onto the SD card in a really easy to read like .csv format. And the same thing with all of the flight settings. And if you don't have a phone, I mean, almost everyone has a smartphone, but if you don't have a smartphone, if your smartphone's dead or like I don't know, whatever, and you can't configure the rocket with your phone, you can always use the configuration file on the SD card. So that's how you can talk to it like in a fringe case. Okay, we're almost done here. There's a bunch of continuity detection stuff on each Pyro channel. That's what all of these are down here. And then up here, this is stuff like stabilizing capacitors. So they're all like 0.1 UF or 1 UF. These are things to just keep all of the signals clean. Oh, and there's a buzzer. A little buzzer goes right here too. So this might look like empty space, like, Joe, why didn't you put things there? And it's because there's a buzzer. Okay, I've done a lot of talking. I've probably missed a good amount of chat, so let's catch up. Are the Pyro channels connected to a MOSFET connected to the 9-volt battery? Yep, it can be any volt battery you want below 16. And yeah, so there are two little MOSFETs, one for each channel. This would be amazing for an L2. Thanks, Chase. What's the processor? It is an ATSAM, ATSAM, ATSAM D21, and I think it's the D21G. It's the same one that is used on Signal though. So if you go to BPS.space/avionics and then scroll all the way down, like the last few computers have all used this processor. So yeah, it's the same one. Is that a hidden message, Joe? I can't remember what I said. I'm so sorry, Jared. Does ARC work in conjunction with Signal or is it standalone? It is standalone. Going up for sale, price. Yeah, I don't know if I should say it yet, but I'm like pretty happy with it. I don't know if I should say the price, but I'm pretty sure of what it's going to be. Maybe I'll wait a little bit. You should stick around. Okay, what's the board for? It's a dual deploy flight computer. BPS is online. Hey Dion, what's up, man? If you have holes in your rocket, it will sink after it splashes down in the water. That is true. Yes. Is the SD card too slow or does it take up too much performance? Why is it bad? So yeah, it's a little bit about speed, but honestly, mostly it's about mechanical vibration. So the way, or just vibration, not like mechanical vibration. Okay, it's about vibration. So the way that these SD card readers work is that you have a little card like this guy right here, and this card on the back of it, on the back of it has all of these little contacts, and the way that you connect with the SD card is like little spring-loaded pins that touch those contacts, and then the SD card becomes part of the circuitry on the board. That's how it works, basically. It's the same way in your computer, same way in your phone. Any cameras do the same thing too. And the problem with that, let me put this back. The problem with that in high-power rocketry is that sometimes there's a lot of vibration on board, and if at any point like one of these pins gets disconnected because of this vibration, you could easily have some corrupt files on your card. So that would be bad news. You wouldn't want that. That's why we log to the flash. At least in flight. And then when it's on the ground, it's like fine, because it's just sitting still. Okay, flex capacitors. I'm falling behind here. Sorry, folks. What kind of material for the board do you use and how do you get it? The board is FR4. It's like a fiberglass material. And how do you get it? You go to almost any PCB manufacturer. They'll etch the board in for you. Okay. SD cards aren't the most durable thing, so maybe, yeah, that's right. So Synergy 7 Studios, you were right about that. It's mostly about having the connection like break during flight because of vibration. Why the name ARC? Charlie can answer that. Charlie Garcia, if you're still in the chat, Charlie came up with it, and he's generously letting me use it for the board. But it's a great name, and look, it's such a good representation of the board too. It's like this tiny little board, and it's only 3 letters. I don't know. I mean, Signal doesn't mean anything either. Signal was supposed to be vector avionics, but then there's this other computer called Vector that's pretty close to what Signal does. So, I don't know. I think people overthink names sometimes. So, okay, called it. Yeah, you did. Joe is never going to build this thing because he will never catch up with the chat. True. Hi, Charlie. You mentioned capacitors, and I made a joke. Oh, yeah, that's right. That makes sense. I've mapped out the entirety of Joe's product line's name. Yeah, that's true. Charlie has other names like that he has suggested that we might use too. I gotta get Charlie on payroll. I have to get myself on payroll. Charlie Garcia of the MIT rocketry fame. One and the same. Why did you choose the microcontrollers and the sensors that you choose? Great question, Peter. Okay, so I guess the best way to do that is just to describe it as we go along. So I'm not really going to describe why I picked them until we get to them. And my goodness, are we ever going to get to them? Because Joey B cannot keep up with the chat. So we were getting components here. So we have 2 out of 4. We need a couple other things. I'm going to look through this. Okay, USB ports. And then we need one more thing, which is the little reset button. Okay, diode, NPN, PNP, N channel. Oh my gosh, look at all these bags. Okay, we don't need that. Ooh, I think these are the buzzers. I hope I got the size right on those. Like half of these components you never see before you order them, and you're just going off like some sketchy drawing in a data sheet. So it's always a little bit of a fun surprise when they show up and you get to see if you did your work right. Okay, they're not in those bags. I'm pretty sure I ordered them. Okay, they're not. Oh, my tea! Oh no, I spilled like a bunch of my tea. Okay, they're not here. Okay, it's not there, that's not it. It would surprise me if it was in a silver bag. IMU. Okay, well it's not there. It's not here. We may have missed it. So let's go through this one more time. So this isn't it. No. 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 Nope. No. No. Neither of those. No. Okay. So it must be in one of these. Oh. No, it's not that. That was kind of a close one though. Wow, what am I going to do if I didn't order these? I actually have a bunch of extras, so that's what I'm going to do, but... Aha! I got them! Here we go. Boom, switches. Okay, I have to get some paper towels because I have tea all over my workbench. Oh. Pour tea. Okay, there we go. Good thing it didn't really damage anything. Oh, and it's delicious. Once again, someone asked what tea I'm drinking. It's Bigelow salted caramel black tea. It actually has some caffeine because this is going to go for a while. And your boy Joey B is gonna need the caffeine. Okay. Let's try to catch up on chat while I get components out. Okay. Someone's gonna pull. Can you pull some strings and get the word geet? Charlie, do you not know Dion? Okay. This is the back side. Yeah, this is correct. Okay, so here we go. This is where these things go. Oh, I made a mistake. Does anyone want to see the immediate mistake that I've already made in designing these boards? So the same thing happens on Arc here too. So these, okay, we're gonna get real close, folks. I hope you're all ready. These little terminal blocks, oh, look at my fingernails. These little terminal blocks have little slots on the side of them so that they can fit together. And if you put them side by side and do one of these, look at that. Oh, wait, hold on. I think you have to go from the bottom. How do you do this? It's, there it is. Okay, so look, now they're stuck together. This is great because it strengthens the component, strengthens the board. It's like a good deal, especially in a thing that's gonna, see some serious vibration. However, your boy Joey B didn't account for this and accounted instead for having like the most frustrating little gap between them. So they cannot really, they can kind of fit together. Give it a shot here. It didn't work initially when I tried it. Hold on. Okay. Yeah, see? Okay, look at this. They It's so frustrating. So I have to move these like a millimeter, I think. At least in the next revision. It's like it's not a deal breaker, but definitely there's a reason that this arc has the letter D1 on it, because that means development 1. Okay, we're gonna turn on the soldering iron. Oh wait, we want to do the surface components first. That's what we're gonna do. So the surface components consist of basically just two things. I did not get a solder paste thing for this, or a solder stencil, because we really shouldn't need it at this scale. Okay. Live antics at BPS. I'm so excited to get both the Aerotech G8 and the Arc computer. The rocket sims for 2 miles. Does it actually? Ooh. I know Gary. So Gary is the president of Aerotech, and he's flying something with an H12, like that was part of the G8 and really long burning development stuff that he's working on. It's an H12. I think it's going several miles in the air, and the rocket's like this tall. Bigelow makes tea now. Ha ha ha, Bigelow Aerospace. They make tea and they make inflatable space habitats. Got him, Dion. Oof. Redrill, oh my. Alright, so we have some solder paste here. Got some lead-free solder paste. And we're just going to put it here, a little blob, and we're going to manually apply the solder paste to the places that it needs to go. Starting with this first little board here. Does everyone remember this? I used to do live streams where I didn't have a solder mask, or not. It's not a solder mask. It's a solder stencil. And this, wow, this is a nightmare. I can't believe I did this before. I already hate this. Okay. And okay, that's probably going to be too much. Then we need some for the switch. And that will probably work. Okay, next. Oh, this is going to take such a long time. What's everyone watching? Got any good TV shows? I have been watching American Vandal, and I'm loving it. So it's like a mockumentary for, I think it's like Making a Murderer or something, but it's awesome. It's like so, I'm just such a fan of the show, and like how, I don't know, I really like it. I don't know what to talk about. I need some more questions. Ask more questions, and I'll try to answer them. Because otherwise, I might lose my mind. Okay. Boom. There we go. And then we have one more to go here. Okay. When are those long burns going to be available? Dude, I wish I knew. I thought it was going to be August, and now I'm hoping it's in September. Like, can you? I don't know if you can order the G8s yet. Does someone want to check online and see if you can order the G8s? I've had like a couple people hit me up and ask like when they'll be available. So the G8s are certified by Tripoli. So they're like ready for sale, but I think Aerotech had trouble getting, they had like production trouble getting the casings for the motors in the quantity that they wanted, like in time. So I think that's what it was, but if anyone knows, you should let me know, because so far my best answer is I have no idea. Uh-oh, I've missed some chat. Okay, honey, I'm home. Hi, Mr. Steven. Paste brush. If you don't have solder paste available, toothpaste works just as fine. That's true. Yeah, Chase makes a great point. If you're trying to solder PCBs and you don't have any solder paste available, toothpaste will do the trick. You just right out of the tube. Okay, the Expanse. I tried the Expanse. I wasn't totally into it. I might have to give it another shot. Okay. I know next to nothing about flight computers. In fact, I didn't even know what this live stream was going to be about. Well, welcome. I'm glad you're here. Ask any questions that you have about this, and I will do my best to answer them. Okay, so here are the USB ports. We're gonna put one on and then answer a question. Put one on, answer a question. Maybe that's a better way to do this. Is like stagger it out. Oh my God. Okay, there's one. Now let's answer a question. Rewatching parts of The Office. Jared, I've seen The Office. I think like all of The Office, maybe upwards of like 12 times. It's unhealthy. BPS hats when? Oh man, I keep meaning to do stuff with merch. I can never gauge how many people actually want to wear stuff with the BPS logo on it. Which is why I haven't been spending a whole lot of time doing it. If you would like be interested in that, either hats or mugs or shirts or whatever, let me know, and then I'll make it happen. Like, I'm not even sure I would wear it. I might. I don't know. Okay. Yeah, really hyped for First Man, for sure. Family Guy. What do you think about the latest BFR update this past Monday? You want to know, Mr. Mansell there, Mr. Richard? So here's the deal. I have been like chanting the mantra that like in order to like explain what Signal does with thrust vector control, that like real rockets don't have fins, except your boy Elon comes cruising in with these massive fins on his spaceship. So, okay. I just finished all 9 seasons of The Office. How high did your highest rocket go? Wait, I'm backing up here. Oh man. Okay, New Moon. Correct me if I'm wrong. You said the 3D printer files with the landing series will only be available on Patreon. That's correct, Jim. So the deal is basically at the different patron levels, you get different rewards. And on like the lower end, you get like early access to updates, behind the scenes stuff. And then at some of the higher levels, you get access to the actual files that I'm working with. So the latest series goes through flight simulations and all of the MATLAB like model rocket landing simulations are available to patrons at that level now. So it's the same level as like having access to the thrust vector control files or the, I don't know, probably, I mean the piston ejection files are already there. I can put them out again. I think I'm gonna do some of the flight computer design files, not for like the full signal computer, but I think we're gonna go through and design a flight computer from scratch, and then I'll put those files on there. Anyway, it's gonna be a great resource, I think, for if like people want to get started with building kind of advanced model rockets like this. But right now, we're at the very beginning of the series. If you want to support, I would be very appreciative, because Joey B wants to build some bigger rockets, and bigger rockets are not cheap. Okay, here we go. There's a little button right there. Then we'll move over, try to answer some more stuff. I am still behind. Okay. Oh, I'm not that far behind. Okay. You need a T-shirt on Teespring. Okay, cool. So people want it. That's good to know. I'll put it on Teespring something like easy with an existing infrastructure setup. BPS patch would be awesome. Did I watch the Delta 2 launch? I did not. I slept through it because I was like up way too late the night before. But I did watch it afterward. RIP Delta 2. The bluest rocket there ever was. Merch would be really cool, but I don't think you have enough of a following yet to keep it selling. I think you're right, Dion. That's like kind of the vibe I get. It would be cool to do like a quick run of them. I'm also like not in the merch game for money, so like I could just spend an hour and put it up. Okay. Well, the next logical step, if you put fins on your rig, I already do. The next rocket will be Planet Express. Why you don't make orange rocket? Okay, these questions are getting less technical. I spoke with my uni space societies about making thrust vectoring model rockets, and apparently they had issues with the MOD. Hey, Will, what does MOD stand for? As they're classed as guided missiles. They are not. Your university is incorrect. Well, okay, so it's not totally incorrect. Basically, the deal is this. It depends on what scale you're working at. So if it's just a model rocket, like, you know, a meter tall and it's using a low thrust motor, that's probably fine. If you're Copenhagen Suborbitals, or if you're Exos Aerospace, or if you're any of these larger, or Maston, any of these companies that launch larger rockets that are guided and that they use GPS, they use a few other like high-grade sensors, that's when it gets tricky. So, and the reason it gets tricky for universities is, so if you're familiar with ITAR, that's the International Traffic in Arms Regulations. There's also something called the USML, which is the same thing. Anyway, these are regulations for preventing the proliferation of weapons technology outside of the United States, and that covers the sharing of sensitive information. So, like, a university cannot teach a class. Okay, and specifically because there are people who are not from the U.S. There are like foreign nationals in universities in the U.S. This gets super. It's like so dry and whatever. If you're not from the U.S. and you're in a university and you take a class at the university called How to Build an ICBM with an active warhead, like, the university is not able to teach that class, and like by a way long level of association, they are not allowed to teach you like everything about guidance for missiles. That is kind of what happens. They can get passes, they can get allowances from the State Department, they can talk to the DDTC about it and get like special cases, but it really depends on what scale you're building. Like, if you're just working with something that's basically an Arduino, it shouldn't be a problem. Okay, that was a lot. Sorry. We didn't like... Okay, we're at 30 viewers. I don't think we lost it. I think we lost one person because of that. Just landed here from Motherboard. Hey, what's up? Harak Hakobian. Nice to meet you. Just landed here from the Motherboard article about you landing rockets. Like and sub from me. P.S. What is the ARC PCB for? Well, thanks for joining. Okay, so ARC is this little guy right here. Oh, that's a little zoomed in. But this is ARC, and it's a dual deployment flight computer for high power rockets. So basically, it controls parachutes on higher power rockets. It does a bunch of data logging stuff too. Oh, Ministry of Defense UK. Uh-oh. Will, Trent, I'm so sorry. I just like mansplained the crap out of you about the US ITAR laws when you are in the UK. So I actually can't help you with that. I actually have no idea what the laws are there. Sorry. Do you know if any liquid-fueled monorockets engines are out there? I do not. Aerotech did a batch of hybrid engines in the 90s and early 2000s, but they're done. Or they're gone, at least. ITAR, baby, why you hurt me so. Oh yeah, Charlie's got it. Rocket motors are certified by NAR. Rocket liquid engines are not and are unlikely to be certified. I built high power I'm so behind. Okay, here's what we're gonna do. I'm gonna take this heat gun here. I'm gonna heat up this solder paste. We're gonna mount these objects onto the board, and then we're gonna put on the terminal blocks, and then we're gonna actually build arc, which is really what we're here for. All right, here we go. Put this here just so it's a little elevated. I'm going to zoom out. And, okay, raise your hand if you've never seen a PCB get soldered before, because it's a religious experience. It is so, so cool. So I'm going to put it that close, and you're going to watch this solder like bead up and become solid. And I'm going to tell you when to look. It's not happening yet, but it's going to happen pretty soon. So pretty soon it's going to start melting. It's going to go into a little bit of a larger pool, like especially around that USB port. So I'm just heating it up. Is it hot? Yeah, it's definitely hot. Our temperature's kind of low. Okay, so see, yeah, it's kind of softening up here. And then I'm going to let it sit for a second. We have to be kind of careful. Okay, it's already starting to happen in your... Okay, so now look at the button. The button's going to be the best example of this. So I'm going to put it here, and here we go. Oh man, there it goes. Did you see that? Isn't that cool? It smells like car tires. Okay, so this is how this works. Basically, solder paste is a bunch of tiny little beads suspended in a gel, and when you heat it up, all of the solder melts and becomes solid, and it's like magic. Okay, I'm so behind. Are we ready? We're gonna do a bit of a speed round. Oh, we're up to 32 people. Let's see if we can get to 40. If we can get to 40 people, I don't know. I have no idea what I'll do. I'll make another cup of tea. I'm going to do a speed run here. Okay, I built high-powered solid rocket of my own. Would love to help and collaborate. Hey, Spliffy, if you're really interested in some high-power stuff, I don't have any need for high-power solid rocket motors right now, but that's really cool. And if you want to collaborate, you can reach out on the contact form on the website. ICBM 105. Sounds like a course I would take. No motor talk, says Chase. Yeah, sorry, Chase. We've memed you before on that. We gotta be careful. When can I buy in Canada? Right now. It's available. We can ship internationally now. I'm in aerospace engineering. I assume major. I've designed liquid engines before and would love to work on small-scale model rockets. Michael, if you want to talk rockets, reach out on the contact form on the website. I want to start a model rocket club at my school. Any ideas on what to do? Probably depends on how your school works and how they like to set up their clubs. I don't have a whole lot of concrete advice there, sorry. Okay, I need to move this USB port a little bit though. You probably want a little bit of funding for your club though. And I bet the school would be happy to help. These motor rockets are not super expensive. Okay, did anyone say hybrid engines? Hi, Dion. Dion, you, me, and Johnny have to do a video on hybrid engines. I've already talked to you about this, but I still have to write the script and figure out what to talk about. If you have ideas for what you'd want to address, hit me up on Facebook. I once saw one take like 9 hours a few months back. Hand raised. Thanks for explaining. I also tried launching a rocket and used an explosive parachute system sometime after the visuals from the National Defense Agency pays me a... What? That seems unlikely. I don't know if I totally believe that. Okay. Does it do the melt? I exceeded the max allowed height of the flight. Oh, that makes sense. Thanks for the different point of view about the missiles. Yep. Can you make an orange signal computer? No, I mean, it looks cool when it's white. Okay, so this is good. This is looking good to me. These ports are all connected. I'm feeling pretty good about this solder job, and the button works. Next, this guy. It do the melt. Time to do the melt again. Okay, 33. We're up to 33 people. Remember what I said. If we can get to 40 people watching, I will have another cup of tea. The stakes are high, folks. Okay. I live in America, so not many guys... Oh, Armenia. Yeah, not many guys launching rockets here. I don't know if I know anyone from Armenia. Okay. Do the melt, do the melt, do the melt. Do the melt! There it goes. Uh-oh. There it is. Okay, now I'm not sure that this one, yeah, we have some bridged leads here. There. That is better. Uh-oh. This is becoming a problem. Sorry, I can't put the camera on here right now. I have to fix this. It did the melt, but in the wrong way. Okay. Well, I have certainly taken a toll on the integrity of that USB port, but those are now good. This looks like a solid board. All right, there we go. And we have one more to go here. How are we doing in the chat? Oh, we're down to 31. We're down to 31 viewers. I'm a little further away from having that cup of tea now. Here we go. Look, Dion, it's like one letter away from your name right there. DIO. Okay, do you use Estes rocket engines or another brand? I use all sorts of brands. Mainly, it's mainly between two brands, and they are Estes and Aerotech. I also use, one motor that I like is branded as Apogee, but here's a quick secret, it's actually just Aerotech and they did a rebrand. Yeah, Estes and Aerotech are, well, those are some of the main suppliers too. You can also buy motors from Cesaroni, a few other brands. Have you thought about embedding magnets into the landing legs and deploying them through solenoids connected to one of the pyro channels? The screws could act as the iron core. Ooh, so you do like the SpaceX game, but instead of pushing them out with like little helium gas things, you do magnets. I have not thought of that, but I think that's heavier than my current solution, which is just rubber bands. So I probably won't end up doing it. At least at this scale, it would be a little too heavy, I think. Okay, that looks good. There's one set of bridged leads here, so I have to fix that. Come on, buddy. Oh, come on, buddy. Stop doing the melt. This is why you need a solder mask. Working at this scale is not a really big problem to like troubleshoot all this stuff, but it makes everything about 1,000 times easier to not do this. All right. There we go. That's gonna help. I just turn this over. Sorry, everybody. I know this isn't on the camera. Okay, and it is ya boy. There we go. That looks good. Give it a little blow. Okay, hey Joe, I'm the other Joe, the guy building the other rocket. Hey man, how am I going to pronounce your name? I'll just call you Joe. I'm going to try to remember that. Hey Joe, I can't remember if I responded to your email today. Ooh, I think I did? I don't know, no rush. Just joined TLDR, XYZT, what's up man? Or gal, I don't really know. Dio, totally intended. What is your best advice for getting into more advanced model rockets like flight software, telemetry, etc.? Okay, Chris, so I think there are actually a couple of good books on high power rocketry. I guess for the advanced stuff, like, I actually don't know. Okay, well, there are a couple good resources. You can go to the rocketryforum.com. You can go to reddit.com/rrocketry. You could do the NAR or EEE, or there's a bunch of rocketry Facebook groups. Honestly, I might ask them about that. If you're looking into like telemetry and stuff, I don't have a ton of good resources for that. Okay. You need the direct solder. Have you ever launched a rocket into a thunderstorm? I bet it would be provided some awesome video and data. I have not. How strong are your motors? Average newtons? Like 8 to 15, with peaks around 30 or 40 at the most. Not today. Rain is fine. I responded this morning. Oh, okay. Rain is fine. Model rocket, high power rock. Okay, I am all over the place. Do you do much helicopter recovery? I do none. I do no helicopter recovery. Our rocketry. I want to build a liquid rocket. Dion, yes! I think that was a joke. Okay, someone posted. Oh, it's so good. Someone posted this great. God, I hope it's a joke. Someone posted this thing in Reddit, the Our Rocketry forum, and it was like, "Hey, I want to build a liquid rocket to get to the moon within like, it was like 2 or 3 years or something. I can't remember what it is. Dion, or anyone who's able to post a link, like, if you can, please do. I actually don't know if you can post links here, but let me just find it. I have to find it. It's so funny. And I read it and initially like had a slight bit of rage because I really thought they were serious for a second. Okay, hold on. I have to find this. Is this it? Trying to design a DIY liquid fueled rocket, complete rookie. No, this isn't it. Hold on, I have to find this. Okay, I cannot find it. Anyway, whatever. It was a silly post. Spending too much time on this. Okay. Thanks for the stream. I'm off now. Bye, Will. Thanks for joining. Polar Bear. What about the 40 people and teething again? Yeah, we're still at 32 people. Share this with your friends. Try to get to 40 people. We need 40 people watching this stream, because then I can get another cup of tea. Okay. What cameras do I use on the rockets? Runcam 2s. They're so good. They're so good. I love those cameras. No links usually. Okay, should I just try to find this? I have to go to Reddit. I think I can post links. Maybe it wasn't moon. Maybe it was the moon. Student moonshot questions. I think this is it. Yeah, this is it. This is it. Okay, I'm gonna post this in here. Everyone has to look at this. It's amazing. There we go. Let me read some of this. It must be a joke. It's definitely a joke, right? Anyway, whatever. Yeah, they wanted to put a rover on the moon by 2022 as their senior project. They wanted to know where SpaceX bought their turbo pumps. They have a budget, a total budget of $10,000. It's amazing. It's so good. All right, it's time to assemble some more PCBs because we're really not keeping pace here. So we have these 3 arc boards now. Let me get back out. These 3 arc boards, and we need to put the terminal blocks on them. And actually, before we do that, I think it's a better idea for us to put the pins on them too. So see, the pins are going to be really like sandwiched in between these terminal blocks. So in order to solder them effectively, we're going to apply those first. Okay. It's such a good joke. Okay, so here they are again, and let's take a look one more time. So these are the pins, and so this is the part that goes on the arc board, and then this is the part that's spring loaded. Isn't that cool? Okay. So I'm not totally sure how we're going to do this. Uh-oh, are these going to touch? I think they are. That's going to be a really big problem. Oh, no, they're not. Oh. Ooh, man. Okay, this is going to be a very real nightmare to do. I hope you're all ready for some Joey B. Ooh, this is not going to be easy. I need to put some water in here and then we're going to get started. This is not going to be easy. Okay, we're still at 32 viewers. We need 40. That's my goal. Who is Carmen? What does the line mean? We don't want to cross any lines without permission from authority or local governments. Isn't that a watch band pin? It might be called that. I don't know if it is. The last sentence. Is the moon dust poisonous? Who is Carmen? I would probably donate, like, if they actually did a GoFundMe, I might donate like $10 just because the joke was so good. All right, where's my solder? Here it is. So this is gonna be really hard to do. So first I'm just gonna like secure it. Okay. But then like needs to be straight up and down. Like it can't, but I can't even touch it because it gets so hot. So how do we do this? Like, am I ever gonna be able to make this work? How is this gonna ever happen? Okay, you guys. I am really doubtful about this right now. Okay. I think we need to get a little creative with how this works. I think we need to get a little creative. We need some type of... Oh! I wonder if I could use a sponge? Ooh, a sponge might work. Okay, let me answer some questions while I think about this. Basically, what the problem we're trying to solve is it's very hard to situate this completely upright on the board because I can't use my finger because it gets so hot that I would burn my finger. I could put a piece of tape on my finger. That would help it a little bit. Let's try this. Here's 2 layers of tape. Alright. So the problem with this is that I lose sensation in my finger and I can't really tell as well like what's going on. Okay. That's not too bad. It's not great, but that's pretty good. This isn't really sustainable though. Ouch. Okay, that's a little straighter. Right? That's not so bad. Let's another fruit fly. I don't even have that much fruit in my apartment. Okay. Oh my gosh, everyone has messaged me. Sorry, everyone. Okay. So, ITAR clearance needed to cross the Kármán line. Is that really a thing? I guess it... I'll trust your judgment, Dion. I actually don't know about that. Okay, hold on. Let me reorient this one more time. Okay, that looks pretty straight. Okay. Who's Carmen? Pliers for the pliers for the rubber band. Drill holes. Put the pins in. Put the board on the pins. Oh. Okay, that might work. I was kind of thinking of making a 3D printed jig that they could sit in, but that would melt the plastic. Put the PCB on first. Use duct tape. Do you actually need ITAR clearance? I sure hope not. Okay, Jim has it. Make a jig. I'm thinking oh, I wish I had a laser cutter. That would work well. Sounds like you need some helping hand there, Joe. Oh! Jared might be right. ITAR is not only an American thing. ITAR is specifically agreed upon by multiple nations. Okay, helping hand. These are called helping hands. I think Jared might have cracked the creme de la creme here. Hold on. This looks straight enough. I might just leave this one. But I think I have a suspicion that this is going to be the way to do it from now on. I'm gonna adjust the camera here in a sec. Sorry for all of the whatever. Not showing this. Okay, so here we go. So this is straight, and then we're gonna take this part of the board. Well, no, because it has to be just this part. Okay, there we go. That's a little better. And then, let me show you what I'm doing here. Where's... Okay, yeah, that's it. so here we go. This is it. Sorry, my hat might be in the way. Oh my god. This is... If... I just have so many doubts about this actually working. I think the helping hand may not be the way, but I do not know the way. Ooh, okay. So, these are not touching, but they are very close. They can also be at different heights. I think that's acceptable, and they are at different heights. Man, this is so bad. Ooh, okay. ITAR only applies to U.S. citizens. Maybe that's the case. Rush, we need to launch anything. Straighten look. Have to realign every time. Iron on one hand, plier on the other, board clamp, a jig for time's sake. Okay. No, I think the jig is long, like, you know, real talk, that's the best way to do it in the long run. But we're here right now. I've got 2 pins in that I feel like all right about. So I think we might just like see how this goes. Ouch! Definitely burned myself there. Okay. Those are straight. And they are not touching. Can we just appreciate how I didn't completely think this all the way through? Look at this. How are these not touching? I promise they're not. Okay, I promise that they are not. However, it is so unbelievably close that you have to hold it up like directly to a light to see through them. This is the worst thing that's ever happened to me. Let me make sure there's continuity between these. Sometimes they break. This is a good way to do it. We could do a little continuity check here. So between the two, yeah, nothing there. I'm doing continuity checks. Here's what I'm doing. So nothing there, right? But then continuity between the top and bottom of the board is what we really, or the top and bottom of the pin is what we're really looking for here. Because if that's, well, that's really what we want. Okay, so here's the first pin. Yeah, got it. And then the second pin. Got it. Cool. All right, this works. This is not a great solution, but it is how we're going to do it. 32. We need to... Okay, can we get to 35 viewers? Tell your friends. Tell... Who's friends with Elon Musk? Tell Elon to tweet it. We need 35 viewers. We're still at 32. Put the PCB on the 2 clamps, use the other clamp. Sorry, you're live. Hey, Joe, do you think your hardware and software could be used on the rocket I've been talking with you about? I need to know more about the rocket you're talking about before I can tell you that. But the answer is almost certainly no. Software, yes. Hardware, no. For something this scale that you want to build, like, you're gonna need to spend some real money on some fancy gyros and a few things. Okay. This can work. But I will tell you, we're probably only going to build 1 Piggy board and then just test it really thoroughly because we can build more later, but I want to use the time on the stream like pretty effectively. And building all 3 of these Piggy boards on the stream is not going to be an effective use of time. Okay, so I think I may have to do this again. Hold on. here, folks. Okay, the pin is in place. Doesn't have to be totally straight there. It just has to be held. Oh, I don't have gravity helping me here, so like the solder paste doesn't totally want to wick around that. Come on. There it is. That's close enough. Okay, and now this is gonna work. We're gonna be all right. Okay, I think this one's a little crooked. I think this one's a little crooked too. Oh my gosh. Okay. Alright, we're at 3 pins now. Whew. You can see where they connect up at this point. We have 3, so we can do a nice shot of this. So here's the Piggy board. Let me zoom out a little bit. Alright, so we have the Piggy board and we have arc. Now, see, there are like, you can kind of see where it lines up. Like right, is that it? Yeah, that's it. Okay, this works. They're in line. Oh, they are just barely there, but there are definitely like test pads where those pins are. Yep. Okay, this works. Oh man, I could not have possibly made this harder, or rather, made this more space efficient. Like arc is so tiny for what it is capable of. Okay, here we go. Gotta put another pin in the Piggy board, and it goes in that one. Cool. And 1, 2, 3, buckle my shoe. Okay, great. I have missed the chat a little bit. Tweet sent to Elon. Thanks, Brian. I have to leave now. We'll keep the video playing so you can have tea sooner. Thanks, Rock. Thanks a bunch for joining. Imagine Elon just shows up in the chat. Tell Elon to plug it next time he's on the podcast. BPS not a thrust vectoring mount when. Bullet dodge. In other words, arc is not thick with 2 C's and 1 K. Or no, 2 C's and no K. Arc is indeed not thick. It's in fact 1.5 millimeters thick. Or 1.6. Okay, that one's pretty good. It needs to be moved a little bit though. Ah, that was too much. Okay, that. Well, that still looks bad. Oh, this is really bad. Hold on. The really good news about arc is that, or at least this Piggy board, only has to be built, you know, like in theory just once. In practice, we're probably going to build several of the Piggy board. But in theory, this has to just be built once. Okay, let's test more continuity on these here. I'm gonna put it so that you can see it a little bit better. Okay, and we're just gonna be testing between the top and bottom. The helping hands did work. Thank you, Jared. Can I answer any more questions while we're on the stream here? I got nothing else to do except for make these pins work. Okay, so confirming continuity on this one. Confirmed. This one. Confirmed. Confirmed. And even this, if it's not totally like... Cool, great. All right, this is good. We have 1, 2, 3, 4 more pins to go. You know, maybe I can just do it this way without the helping hand. Oh, I kind of need them. Okay, this looks all right. This one's a little crooked. Oh man, okay, almost there, folks. Ooh, that's a good one. And they're still not touching. Let's confirm this with a continuity check. I should stop unraveling this. Confirmed. No continuity between them. Very nice. I sent the link to Elon. While you do this, I'm working on my BFR inventor model. Nice! Okie doke. Here we go. 3 more to go. I'm feeling pretty good about this. We have a bunch of pins on the Piggy board. Yeah, I'm feeling pretty good about it. How many millimeters is the buzzer? You know what? Let me try one thing real quick. Where's the buzzer? Because this is really the constraint on these things. This is really where the constraint exists. What's everyone else doing while Joey B's burning his hand? What do we got going on tonight? Oh, did I order 6 of these? Nice. Okay, so here's the buzzer. Ooh, this will be fine. And the reason is because the Piggy board, yeah, so these pins have to be above, like, they have to be above the plane of the top of this buzzer. And they are just above it. Ooh. Once again, the tolerances on ARC are like kind of insane. Elon Musk says, "You're hired." What's my job position and what's my salary, pal? All right, here we go. Let's put these back because we don't need them right now. Who's got the Elon Musk account? Oh, wait, this is broken. Hold on. This goes in here. I just woke up again after passing out post-launch day, and I'm now drinking and watching my buddy solder. Yeah, Dion, did you guys end up launching anything? I know you didn't launch the thing that you were thinking you were going to launch, but did anything happen? Okay, we have three more pins to go, and then we can move on to these, which are much easier to solder. I'm going to put this here, put this here, and bingo, bango, bongo, there we go. solder this real quick. That didn't work so well. Nice. Okay. That looks good. Getting pretty quick at this now. Gonna readjust. Easy peasy. Easy peasy beautiful cover girl. That's the slogan, right? Oh, good job, Joey B. Look at that. These are all in line. This one's a little crooked, but this is gonna work. It's gonna be okay, everyone. It's gonna be okay. Whew. This getting by the skin of my teeth. The skin of my teeth is thicker than the distance between all of these pins, which just barely do not have problematic continuity between them. Just barely. Okay, cool. There's that. This one's a little harder to get it to stand straight up because we don't have a good reference. That looks right. And that looks right, so we're just gonna leave it. Okay, we've got one there and one more to go here. See? Now it's a little bit easier once you get the hang of it. Okay, this one's gonna be real crooked. And there we go. Okay, and then let's reorient it here. Okay, and then another do it again here. Okay, this looks pretty good. Okay. Okay, one more time. It's really hard to get these lone pins to cooperate. Okay, that's going to be good enough for now. So here we go, folks. This is the Piggy board, and this is ARC. So I'm going to put them side by side, and you're going to see where they connect up. Now they're going to be mirror images of each other, but you'll see that they do actually connect up. So I'm going to point out the test pads that are actually going to connect to these. So the ARC board is actually going to be flipped over like that. So here we go. 1, 2. These are the ones at the bottom. We have 1, 2, 3. These are these 3 here, and then 1, 2. These are these 2 right here. 1, 2, and that's these 2 right here. Isn't that crazy? That's insane. I've missed a lot of chat. Sorry. Okay. Chief Pin Solderer. Nothing at all. High-speed winds. Just broke everything down, and we're home before noon. That's too bad. Did I see the Cleveland Browns finally won? I follow almost no sports. I am so sorry, Jim. But congratulations, or condolences. I'm not sure, depending on how you like the Cleveland Browns. Would have liked to launch a garbage bag with our 6-kilogram K&SB motor. I really should use these pins in the BFR. Thanks. I'm loving the Elon account. Hey, do you have good sources for getting into PCB design? I've only ever used perf board and things of that sort. The Great Papo! Welcome to the chat. Yeah, okay, so look up Jeremy Blum. Jeremy Blum on YouTube. He has a great tutorial series on PCB design. Really recommend it. It's what I used. I also had help from my buddy Arsenio, who knows how to do PCB design too. Okay, the Red Sox beat the Yanks. I'm into that. I like the Red Sox because I'm from Boston. Easy breezy. Just advice from an engineer to another engineer. Never use the word oops in rocket science. Dion, do you know what happened with Stratos 3? Can we get into that here? Do we know what happened? Do you have any... I know there were some accelerations that you guys saw, right before RUD, but I would love to hear what actually, went down. Hi, Tree TG. Okay, cool. So, now, these are kind of lined up. I don't totally trust it. Let me just do some scoping out here. Yeah, this one's a little tilted. We're just gonna try to get these pretty close. Okay, that looks a little bit better. Yeah, so those both touch. I think... Oh my gosh. This is just unreal. It is unreal that this can actually work. Yeah, they all touch. They're all there. That's insane. Okay, we know what happened. Not allowed to tell anyone. Very sorry. That's okay, Dion. It's cool. Never order PCBs from China. That's what we did for the first Falcons, and that's the reason they crashed. That's not true. It's not even slightly true. China also does a great job making PCBs. So, launch site apps, just keep it confidential. No worries, Dion. What a boring hat. Okay. Hey, James, what's up, man? Welcome to the chat. Okay, so we've done this. I'm just going to assume this works. I'm probably just going to keep this on so I don't burn my finger again. Now it's time to put these guys on. So these go on this side, and that's what we're going to do. I'm going to zoom out a little bit because we don't need so much coverage here. All right, well, I'm almost out of tea, folks. Can we try to get to 34 viewers? I would get some more tea with 34 viewers. We're at 32 now. I just need 2 of you to either open up another window or get someone else to watch. I'm officially out of tea. So, it's time. I'm watching. 32. We're still at 32. Am I blocking with my hat? Hello? Okay, there's 1 and 2. Boom. Done. That's pretty nice and easy. Okay, still at 32. Still at 32 viewers. Or get out your phone, watch it on your phone and the computer at the same time. Doesn't have to be a true 34 viewers. Okay, hold on. Okay. 36, 35. Wait, where are you guys seeing this? I'm not seeing that. I'm still seeing 32. Should I refresh? Let me refresh. Oh, 29? We went down. I refreshed it. It went down. Uh-oh. 27? What's going on? Oh, dear. I'm getting memed. Okay. There's that. 29. Okay. We're back up to 29. I'll settle for 32. I'll settle for 32 now. Okay, wait, don't refresh. I wonder if refreshing makes it work, or makes it go down. Okay, nobody refresh. 27. Nobody refresh. We're just going to leave it up and see what happens. Okay, we're almost done with this. 26. This is... Everyone's leaving. Okay. Here we go. Very nice. Okay, cool. So, this is the Arc Piggy board. It's a little bit crowded, but looks pretty good. 27. We're just going to finish up the soldering on this. And right here. And right here. Okay, and that is a fully done Piggy board. So, this little board connects to Arc. Here we go. This little board connects to Arc. And then when you put them together, like that, that's how they look. And then you plug in with a USB cable and talk to Arc through the USB cable or through any of these terminal outputs, which I'll use like an Atmel ICE or some type of debugger or programmer to actually talk with Arc. All right, we're at 28 viewers. Can I use an Arduino to get rocket telemetry? Yes, you can. Is it ethical to illegally download a game that I owned as a kid and bought 2 copies of back in the day? I think probably, if you bought it already, you're just downloading another copy. I don't know. I have no idea. I'm certainly not the authority on this. Okay. Hello? 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 Okay, we back. I don't know what happened there. Okay, well, there we go. Sorry, folks. Sound is gone, and now it's back. So, listen up. I'm going to take a quick break, but before I go, I have a question. Do we start by building the back of the board, which is very complicated, with a lot of components, or the front of the board, which is a little less complicated, but not really? So put it in the chat, say back or front, and I'm going to be back in 2 minutes. Do not go away, and please visit the link on the screen. Okay, hello again, everyone. It's me, your boy, Joey B. And here, wait. Shh. I have, if you notice, there's a little bit of smoke here. I have here my new cup with a different type of tea called Sleep, which we're just gonna ignore the name for because it's just a really good flavor of like chamomile blueberry. All right, ready? Here we go. Aha. Yes. Okay, there we go. Now I have to put this over here. Okay, yes, welcome back everyone. We're back. This time we're going to actually be building the ARC board instead of just the Piggy board. And it should be a lot easier than building the Piggy board because that was kind of a nightmare. So let's go over to the workbench here. This needs to cool off for a little bit. All right, so I'm gonna scroll up on the chat and we're just gonna check this out. It looks like everyone wants to start on the back of the board, which is great because we're just gonna get all of the bad stuff out of the way here. Okay. Is it ethical for me to illegally take over control of PayPal if I create it? BBR, it's the Barnard Bathroom Review. Before you number 2, check the review. Thanks, Jim. Okay. Do I study electronics? Nope. I'm all self-taught. How exactly do you go about detecting apogee with an IMU? Not like actual code, just a rough idea. You don't do it with an IMU because as soon as the rocket is in free fall, you cannot detect like most accelerations. You can detect drag, but free fall for like as soon as the motor burns out, your rocket is in free fall, even if it's still moving upward. It's under the influence of that 9.8 meters per second squared. So you have to detect it with a barometric altimeter or some other type of altimeter. And what you do, you can do it in a couple of different ways. I do a general average. And then I look for a certain rate of descent. And really, I'm actually looking for the non-existence of a positive trend. So I'm not actually looking for apogee. I'm just looking for when the rocket stops going up, which is basically apogee. You could also do it. I think you can do it with standard deviation. I don't know. That seems needlessly complicated, though. I think you just do a running average and then look for the rate. Okay, that's how you do it, and that's how you do it with the barometric altimeter. We are going to have, by the way, hey, this is another great opportunity for me to plug some stuff. So this new series, Landing Model Rockets, we're going to cover all of these things. So in the video about flight software, we might do a video just about sensors and like what kind of sensors we need on the rocket. But in one of these videos, we're going to talk about this stuff. So get excited. And if you aren't already, and if you are interested, we have a whole Patreon so you can get a bunch of extra like incentives as this video series comes out. So you can get actual flight software, or well, you can get some of the flight software. You can get flight computer designs. We have flight simulations. Going to have the 3D printable files for the thrust vectoring mount. All of these things will be available at patreon.com/BPS_space. There's links for it all over the place. There's a link in the description. Okay, now that my little ad read is done, let's build the ARC board. And we're actually going to build 3 of them here. So 1, and back this out. Here we go. 1, 2, 3. Beautiful. Look at how nice these look. Oh, I love it. Okay, cool. We're going to get rid of these Piggy boards because we don't need them. We do have to do a little bit of housekeeping here first, so we have to clean things up. Okay, here we go. I'm going to put these back in the bag. You know what we could probably do too? I'm going to tilt this down. There, that's a little bit better. Okay. Hey, by the way, I don't know if the sound is going to cut out again, but if it does, just like spam the chat with the word sound, and I will reset it. I'm not sure why that happens. Okay, so we need to do a little bit of cleaning here so that we can organize ourselves and build this more efficiently. Let me catch up on the chat. Don't spaghetti the board. How do I BPS impulse from Launchpad 2.0? What? That question makes no sense. Do you still need people to fly supersonic? We are definitely filled up. We have definitely filled the slots for supersonic flights. I'm sorry to say, I like way more response than I actually wanted for supersonic test flights, which is great. Everyone's just really generous with like their payload availability, but that's not what I expected. Okay, so we're all set with that. And those are going to mostly take place in late October or early November. Maybe early November. Okay, here we go. Do you use a gyro, and if which, the MPU 6050? It's not the MPU 6050. I can't remember the name of it. It's one of the ones from ST Microelectronics. It's like it's the same class as that, though. You can use the BNO 055, you can use the 6050, you can use the, what's like the 9050 or the 9020. All of these are basically the same quality gyros. They're all around the same price range, too. Okay, so do I plan on building a supersonic rocket? Not really. Not right now, at least. I just want people to fly arc on it. So there's really weird things that happen to altimeters once the rocket goes supersonic, and that is why I need these test flights. Okay, so what I'm going to do here, the reason I'm doing this like housekeeping, that's what I'm calling it, is because it's going to be a lot easier to build this if I have piles of different types of components, rather than if I just have to sort through all of the bags every time. So, resistors are going to go here, resistor, capacitors are going to go here. Resistors, capacitor, res. I'm going to write this on a piece of tape and put it on the table. We are not going to forget this. This is going to be RC. RC. Cool. Okay, capacitor. Resistor. Ooh, inductor. That goes over there. Resistor. Resistor. Resistor, capacitor, resistor, inductor, capacitor. These are garbage. These we don't need at all for this board. I'm just going to put these over here and deal with them a little bit. We don't need this. This is capacitor. This is resistor. Oh, a switch! Cool. We don't need that right now, though. Inductor. Crystal. Oh, capacitor. 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 Resistor. Almost there, folks. We don't need these. What is this? Oh my god. Who ordered this? Who placed this order? This is disgusting. Okay, hold on. Let me get this out of here. The best part about this is like, this has no business being on a piece of tape like this. Okay. Look at this! This is it! Are you kidding me? Do you see this little section? This is all I ordered in between here. These other ones are empty. See this? They're empty. They gave me this much on a plastic spool, and this is what I actually needed to use right here. Excellent. Let me cut this. And there. And what is this? This is a capacitor. This isn't even like a lot of components. This is crazy. Alright. Okay, hold on. I did not expect people... They may... I'm falling behind on the chat. I'm just wondering, how long did it take you to teach yourself? Because I'm 15 and I know everything up till RF transmitters and receivers, and it's been 2 years of me learning from YouTube. Like, you're not done learning. So, infinity time. That's my answer. I have... Like, you don't... like, I knew how to do this stuff a year ago, but I'm way better at it now. And I knew how to do lots of things a month into learning this stuff, but like, it's like a curve. Okay, we need a plastic bag for these, I think, because I'm not going to keep them in that massive bag. 1 second. Okay, so let's write this on the bag. These are cap, that's ceramic capacitor, 22 picofarads, 0603. Cool. Okay. These go in here. Just doing a little sorting here. This is a barometer. On your launch pad, it says BPS impulse computer. James, I will sell the impulse computer. I might actually just open source it. I don't know. The software is really modular, so it lends itself really well to being opened up like that. Okay. I'm rendering an animation of flames for the BFR. My laptop is currently not a fan. I would say your laptop is a fan. Like one that blows air. Okay. That's an order form. Alright, we need to do a little bit more sorting here. So I'm going to move some stuff around. I think this is going to go here. My computer is going to go here. That works. This goes over there. We're almost done, and then we can start soldering. Well, then we start placing components. Okay, so these are fancy sensors go up there. This is something that we don't need. We don't need this. We don't need that. We don't need this. We don't need... Do we need a button on ARC? Does ARC have a button? I don't think it does. We don't need that. We need these. These are crystals. Switch. Okay, yeah, this is what we're going to do. Alright, so here we go. This is the LED that goes over here. This is the linear regulator. This is the 3.3 regulator. This is the 5-volt regulator, which goes on the floor because that's for a different computer. This is the flash, goes over here. This is the Bluetooth chip. This is an N-channel MOSFET. This is the SD card reader. These are switches that we don't need. Whoa. Hold up. Oh, that's the processor. This is the flash. Okay, cool. This is the IMU. Here's another resistor. And, okay, 16 megahertz crystal, a NPN transistor, a diode, another resistor, a PNP transistor, and what? Oh! Oh, that's right. Okay, I have two different types. Hold on. I have two different types of voltage regulators. I forgot about this. Okay, so one of them puts out 600 milliamps, one of them puts out 500. And we want the one that puts out 500 because this one can tolerate a lot more input than this one. And this one's for arc and this one's for impulse. Okay, impulse. How many did I order? Hold on, guys. 3 of those, 3 of these. All right, well, we're going to open up the schematic and just confirm here, because I don't want to mess that up. That will fry our board for sure. Okay. In need of the launch computer. Yep, Chase, it's coming. Okay, I'm sure the fans. Why don't I make a BFR model? I will, but it's not a priority right now. BFR. Okay, here we go. Hold on 1 second, folks. And just open up this. Oh man, none of my layers are turned on. Okay, boom, there we go. Now, okay, so here's the regulator, and what is it called? It's called... Oh my gosh, okay. I think... Oh man, DigKey... Sorry if this is not interesting. It will be done quite shortly. But I need to make sure that I'm putting the right regulator on the right part. So the APK, that's for the older computers. I'm pretty sure that's the lower current regulator. Oh, come on, DigKey. Ah, there, come on. It's so slow. Oh my gosh, okay. DigKey, you are killing me, dude. Here we go. Okay, this one, the SPX. Yes, okay. I was correct. This one goes on the ground. This one goes on arc. Got him. Okay, so we're ready now. And let me put away these little helping hands. Okay, does anyone remember what the best part about arc is? I'll tell you, it's this. Because we have a solder stencil that is made for arc. Where, oh my gosh, is the actual thing? There it is, look at that. So this is the stencil. This is how we're gonna get solder paste onto the right parts of the board. Okay. And all I need now, 2 pieces of blue tape. Okay. Will the stream be uploaded to YouTube to watch after? Yes, it will. Thank you for being... okay, hold on. Hey, Joe, it's Jack from SEDS ASU. Hey, Jack, what's up, man? You're, okay, you're Captain Jack, right? Give me like a yes or a no. Like, if I say Captain Jack, do you know what I'm talking about? Okay. Hey, Jack. Accidentally switches to desktop view. How did I design the Bluetooth antenna? Antennas are magic. Here's the thing about antennas, is no one actually knows what's going on. Okay, Jack, yes, on Instagram. Anyway, welcome to the stream. So, yeah, antennas, especially something like... Well, Bluetooth is not like crazy high frequency. Anyway, whatever. Antenna design is hellish. You can do all the math, you can do all the calculations you want, and it still might not work. So, oh, by the way, I am just cleaning my boards off because that's a good idea in case they have dirt on them or whatever. Yeah. So the antenna design is basically a derivative, a really close derivative. Oh, and the other thing is you want your antenna to be a function of it's a function of, what is it, like the wavelength, I think? Yeah, the antenna has to be a function of the wavelength because that's the only way you can really amplify the signal. It has to be a, like a derivative of the wavelength. It's not easy though. So mine rips off other designs that I know have worked. And that is how you do antenna design. You can also, there are tools like in MATLAB, you can actually simulate how an antenna is going to work and find the strongest pattern. Like there's a real way to do this, and right now this is just what it is. Okay, so here we go. We're going to put these 2 pieces of tape on here. move this to the center. And I'm going to put solder paste on here. So this part, it's a good thing that Ben isn't watching because he hates when I do this. This is not like totally the right way to do it, but okay. That looks pretty good. Okay, so now the board is on, which means see right in the middle here, all of these exposed pads are under the like the solder stencil. So all of those exposed things that are on the back of ARC, all of the parts that should not have solder on them are covered. And that is what this is for. Now, we have this little spatula, and we're going to use it to put the solder on the boards. So I'm going to put a little solder on here. I don't know how much we actually need, but so there's our solder paste. And then I'm just going to squeegee it on. Okay, that's plenty. And then I'm going to scrape it off so it's the right height. And then we'll take the, oh my gosh. And then we'll take the board off. I do that like 2 out of 3 times. Okay, and there's our little board. Look at that. It's got the little solder bits on it. Now we'll do it for another one, and before we do that, where did I put that paper towel? Did I throw it away? Okay, hold on. Oh my gosh. Sorry everybody. Here we go. So I'm just going to wipe this down so there's no excess solder paste that could mess up the silk screen of the other board. Here's the next board. We're going to put this here. No, this is the wrong way. I will get to the chat in just a minute. If you have asked a question and I have not answered it, it is because I want to finish this part first. So here we go. We'll line it up. And that looks all right. Looks pretty good. So I'm going to tape it down. Okay. Boom, done. Okay. There's another little board with solder paste on it. And then we have one more to go. Once again, we're going to wipe this off. Okay, here we go. Turn this over. What am I hitting? Oh, it's the side of the chair. Okay. Man, is this a quality stream or what? Alright, here we go. Line it up. 1, 2, 3. Buckle my shoe. Boom. Got him. Oh, that's off center. There, that's better. Okay, and here we go. This was like the perfect amount of solder paste too. Okay, boom. Done. Wow, this was totally worth it. Sometimes the solder stencils are not that cheap, but it's really, really worth it. I'm going to take these off because we don't need them. And I'm going to wipe all of this down. And get all of this excess solder paste off. You want to do this with a dry paper towel because with a wet one it doesn't work so well. That looks pretty good to me. Yeah, that looks good to me. Alright, nice job. So that's done. I'm gonna wipe off. Oh, here. I'm gonna wipe off the excess on the solder paste spatula here. Cool. There goes another thing on the ground. There we go. Okay. Hello again, chat. Thanks for sticking with me. How do I design? Okay. I want to build the same launch pad and rocket. If you ever, IDK, if you can ever answer this, but how do you have the gyro data tell the motors which way to move? It is super complicated. That's actually not that hard. I don't know. You want me to go into it? I'll do it. So I can answer it. It just will take a long time. Okay, so let me try to speed run this. So the gyroscope data comes out in a rate. It's a rate of degrees per second or radians per second. If it's radians, you have to convert it to degrees, or I guess you can work in radians if you want. But it comes out as a rate. That rate is not orientation. So you have to integrate the gyro data on an X, Y, and Z axis to get the orientation of the rocket, like which way it has turned and things like that. Except it's actually, that's the hardest part of all of this, is how do you integrate the gyro data so that all of your axes are correct. So when the rocket turns like this way, okay, so the gyro sensor, when the rocket turns this way, is correctly saying it's moving on, we'll call this the x-axis, and if this is the y-axis. So it says it's correctly moving on the x-axis. But what if you're turned this way already, you're like 10 or 20 degrees over at the y-axis, and then you move this way? The gyro sensor is going to see this movement, because this is the same, the gyro sensor has moved. So it's going to see this as the y-axis, or the x-axis. And that is not actually the case. So you have to do all of this fancy math. You can either use direction cosine matrices or you can use quaternions to determine what your actual orientation is through the rates. That's the hardest part for sure. Then you use a PID controller to have a set point, and the set point is where you want to direct your rocket. It's like where you want the rocket to point. You could say 10 degrees on the x-axis and 20 degrees on the y-axis. That's where I want my rocket to fly. And the set point can change. You can modify it if you want, but you did a set point for your PID controller. You feed the orientation as an input into the PID controller, and you continually update the set point if it's anything but 0, which is like straight up and down. The PID controller generates a signal that gets sent down to the thrust vectoring mount, and then also if your mount is geared, you have to deal with that after the output of the PID controller. Oh my gosh. Okay. It's like a minute and a half. It's not that bad. Okay. Did you see where I said I'd rep BPS at Narcon? Like I had. That would be cool. Let's see if I can get to Narcon this year. I'm trying to tell a stepper motor to move in unison with the gyro chip remotely. That shouldn't be that hard. Yeah. Anyway, okay. We have to get building, folks. We've been streaming for like 2 hours now. It's time to start building this stuff. So, let's start. Oh man, I know none of these. I really know them well on Signal, but I don't know any of these. We're going to start with these bottom two. So, okay. We're going to go to the bottom here. B. So I've got the, what I'm doing here, if you're wondering, like, what is he doing on his computer? I've got the schematic open and the board design open so that I can actually just reference it. All right, so here we go. Oh, this is, I have to think about this differently. This is on the other side. So 180 ohm and, okay, 1M on the B. So we'll do all of the 1M components first. Okay, 470. Okay, 1M, 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 and that's it for the 1Ms, I think. Yeah, 1, 2, 3. So, our first component, ladies and gentlemen, is a 1 mega ohm resistor. Can we clap it up? Let's clap it up for the 1 mega ohm resistor. Great job resisting so much current. Just really, really good job. Such a great resistor. Yeah, I mean, what a guy, right? Okay. Am I losing it yet? So I need to get this to come off. There we go. That's gonna work. Is it? These tweezers are dying. These are like a year and a half old. And they're dying already. Okay, so here we go. Okay, we need 3 per board. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, sorry, you can't see this on the camera. I'm like putting them on the thing there. Maybe well, let's just do this. We'll leave it here. Okay, one goes here. One goes here. And one goes, oh, these are kind of easy to place. One goes here. This is not that bad, actually. Somehow this is like way easier than Signal. Maybe it's because the board is so small. I don't know what this is. I don't think I like changed the like landing pad size. Okay, there we go. And then one goes here. Oh, we're gonna cruise through this, guys. This is gonna work. We're definitely getting this done tonight. One goes here, one goes here, and the last one is right here. Okay. Let's look at some questions. Oh, clap! Clap it up, everybody. I love the claps. 1 mega ohm. Is everyone awake? I'm drinking my sleepy time tea. Mmm, delicious. Okay, what's next? This one, 180. I don't think that exists anywhere else on the board. So, great news. This is going to be an easy one to place. Oh, look at that. Oh, no, that's 100K. Here it is. Yeah, this exists like 2 places on the board. What's going on? We got 28 people in the chat, and I don't know, do you got questions? Do you need life advice? Ask me for life advice. Let me try to give you some life advice. Doesn't have to be rocket related. We're just like having a great time breathing solder fumes here, so I'm trying not to lose my mind. And that's the life I'm living. Okay, here we go. So 1 right there. Can you see this? Yeah, you can kind of see it. 1. Oh, I should turn my hat around because it gets in the way. Yeah, that's better. 1, 2, and 3. Boom, done. Microcontrollers, any favorites? Yes. Man, the Teensy series of microcontrollers that Paul Stofferigan, I can't remember how to pronounce his last name. Anyway, PJRC, Teensy microcontrollers. Those things are amazing. If you're just talking about like a full board of microcontrollers, if you're talking about actual processors, the answer is basically the same. It's the MKDX256. Hold on. Hold on. It's okay. MK20DX256 VLH7 processor. It's an ARM Cortex M4, and it's the thing that exists on the Teensy 3.2. It's a really good processor, and NXP does a god-awful job of keeping it in stock. All right, we got to put some more components on here, folks. All right, 1 there. 1 there, and 1 there. There are 3 of this next item, which is a transistor, And here it is. Sleepy time was in Scott versus the world. Oh, I get to label this one. Let me make sure that I label this correctly. D. MOSFET. So this is a MOSFET. This is used to trigger the pyro channels. And I have a really hard time, I'm not going to be able to totally explain why in a succinct way, but I'm actually testing out completely shutting down the Bluetooth chip with this too. So the Bluetooth chip runs on what is basically a separately controlled power source and can be totally cut off. Okay, 1, 2, 3 per board, so 1, 2, 3, 4, 5, 6, 7, 8, 9. And they're gonna go right here, right here, and right here. Boom, done, got him. All right, Joe, should I build my own RCX reaction wheel system first? Charlie, you should do what your heart desires. I can tell you if you're waiting on the BPS RCS system, you might be waiting for a while. I mean, the schematic for the computer's done, but I don't have a whole big interest in doing a more PCB routing anytime soon. So we shall see. I would say maybe do the reaction wheels first. Actually, Pixida could probably do the RCS stuff too. You have an IMU, you have a powerful processor, you have a bunch of outputs. You just need to do the well, whatever. I'm not gonna diagnose your flight computer on the stream. I'm not gonna tell all the secrets of the MIT rocket team. Okay. What else? What else we got going on? I don't know if someone has mentioned the plant already, but blah blah blah, something about the plant moving. You can't even see a plant in the frame. Do you prefer DigiKey over Mouser? If so, why? I do. I think generally speaking, DigiKey is a little bit cheaper. And I also, here's a really bizarre reason. So my dad he works for a company that makes engineering software. And he gets catalogs from DigiKey all the time. And when I was a kid, I used to look through he would bring them home for me. And I used to look through the DigiKey catalogs for all sorts of just bizarre things that they have in stock. I always thought that was kind of funny. So I have this bizarre reason that I prefer DigiKey, and it's because it's a little bit nostalgic. I just wanted to say I just found you, but you are amazing. I wish I could afford your stuff. Thanks, Chris. Okay, well, let's talk about affording things. So Signal is an expensive computer. There's no backing down from that. It's an expensive item. It's an expensive kit. Arc is going to retail. This is not super official. And it could be subject to change, but if everything that I have in my mind is correct, it's going to retail for $99 US. So it's, in terms of the functionality, it is a far better deal than Signal is. Not better deal, it just it benefits a whole lot from all of the processing stuff that happens on Signal. So the full Bluetooth control, all of that stuff, it exists on here too. Everything basically but the thrust vector control. Okay. Charlie says Pixida can do both. Go for it. It's all public. Anyway, I mean, I have nothing else to say. MIT has some fancy rocket computers. That's the moral of the story. Okay. What next? Let's do, what's this one? One, and there's another one here somewhere. Nope, there's not. Okay. 1K. So we have a 1 ohm resistor now. Do I have an oscilloscope? I do not. Those are fancy though. I would like to have one. But so far I have been able to avoid needing one. Although there are times where it really would have helped me diagnose things, for sure. Okay, here we go. So, 1 goes here. One goes right here. We get one right here. So on the edges of the board, really. One right here. Like all of the manufacturing for stuff for ARC is right at the edge of what the PCB manufacturer was able to do, basically. They could go, like, in terms of the reasonable drill sizes and stuff like that, it's all right up against the wall of the specs. As small as it can possibly be. Okay. So that's good. Okay, next, let's do these two. Here we go. So 470, 470. And I don't think there are any others that are Oh, there's one here that's 470. So 3. Okay, here we go. Okay, ask more questions. More life advice. Do Joey B's life advice corner. I have nothing else to talk about. I'm just going to run out of things and start losing my mind. Okay, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 1 goes here. And then 1 goes, should probably just double check this, but I think it just goes right here. One, 2. Yeah, that's it. That's right. Okay, 1. Does building rockets help attract women? I can tell you no. I can tell you, generally speaking, it does not. What else have I done? I don't know. I've shot video, I've played music, and I've built rockets. I don't really see a big difference between all of them. It's about the same level. Here's some life advice. Doesn't matter what you do. Okay. And 1 right here. And, okay, here we go. So 1 right here. Then 470 here. And 470 here. Okay, great. Very nice. Do I fly any RC? Anyone into S? Okay, do I fly any RC? I really want to get into FPV racing, but I cannot justify spending the money right now. So, another day. Good question, Jared. I don't know, man. I wish you would respond. Okay. Okay, O.1, there must be And are we back? I think we're back. I think we're back. Sorry for the sound, everybody. Okay. How are we doing? Are we back? AOS? We got an AOS from Bluegill Bronco. Back. It was repeating the sound I made. Wow, that's really weird. I don't know what's going on there. Okay, well, back to work here. Do I ever plan on making this a company rather than a one-person endeavor? I would like to, but we need more revenue to make that happen. We could always do like internships, but I don't feel comfortable having anyone work as an intern until I can realistically have like an idea that I could pay them at one point. And so far, things are just like too up in the air for that to be the case. Okay. 1, 2, 3. 1, 2, 3, and 1, 2, 3. Boom. Oh, and these are sideways, right? Yes, I'm pretty sure they are. One. Yeah, these are sideways, and this one's vertical. So we'll do the vertical one first, which is right here. And then here we go. What about one? And one right here. Okay. I'm 16, but I'd love to do stuff here with pay or not. Well, I'll keep you posted, Chris. I would love to have some extra help. There are definitely times where I'm like, oh my god, I could use 3 more people working on this. But for now, I think it's going to stay a one-person operation here. Okay, here we go. And boom, done. Okay, one more. 3, 2, 1. Blast off. I wonder if any of these are going to fly. They might. I'm not sure if these ones will fly or if these will just be like ground test units. I'm going to need to do another run for the supersonic payload, but we will see if they fly. Okay. I just started college too, so perfect time for a BPS internship. How do solid thrusters control thrust for landing? Can you give me some more details on that question? Why do you put so much effort into making the rockets look so real? Because that's like the most fun part. Hold on, let me just update this here. 10K, 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 10K. I think there are just 4 of these. Okay, so, because making things look real is what I have loved for a long time. So, here it is. Yeah, like when I was a kid, I really loved model trains, and like the goal with model trains is how realistic can you make your train layout? And I'm trying to think of other things I really like that were realistic, but I guess it's just trains and rockets, I guess. Yeah, and like any modeling industry, the most success that companies find in it is when models, this is like a mantra at this point for BPS, but when they look and work like the real thing. Anyway, that's why. Just tweeted a clip from the stream. Is it a good one, Jared? What did you tweet? I don't want to watch it right now, but I'm a little worried. What servers do I use for TVC? Attempted to build my own, but having problems. Well, Larry, I can show you. 1 second. So we do. Here at the Rocket Factory, we do all sorts of quality control. So these are QC, quality control passed, 9-gram servos. And boy, are there a lot of them. So they're in pairs here to ship. They're like ready to ship with Signal. But this is basically what they are. I really like this brand. This is the Osoyo Micro Servo Motor SG90. You have to find a brand that works well though, because some of these 9-gram motors are like pretty shoddy and have a lot of play in them. These ones are great. But you kind of have to try a few brands, honestly. These are definitely good. You can find them on Amazon though. Okay. Not sure if they will pass QC now. Bees? Are we getting the bees again? No, there's no bees. This is normal. Sure, you're talking about bees. Can you do what real companies do and drill the core to predictably control thrust? Yeah, but I don't make my own motors, Chris. I'm quite a bad chemist, so I don't make my own motors. Yeah, that's the answer. Okay, bees. How do I control landing? Oh, how do you control landing? Do you control the thrust one time? Do you control the thrust or time just right on landing? No, so there's solid motors, which means that you cannot control thrust. You can only control when they start burning. And if you become a patron, you can see the new video that actually shows like that demonstration. I demonstrate how it is possible through a simulation to use a non-throttleable solid fuel engine. And if you're a patron, you can have early access to that video. And the link is in the description. Hashtag ad, hashtag plug. Okay, here we go. This is a resistor here. Let me just make sure this is the right one. It's been a hot minute here. Yeah, 10. Okay. 1, 2. 3 and 4. We're moving along here, folks. Making some good progress. 1, 2, 3, and 4. Okay, we have 4 more to go. 1, 2. Okay, and then we need 2 extras here. Not sure if it'll pass QC now. Okay, here we go. Open this bag. The fact that you can do this is amazing. I asked my friend one time if he thought it was possible, and he said no, that you were doing it. It's so freaking cool. Thanks so much, Chris. It's really nice. Okay, we have 2 more resistors to place here. And there we go. 1, 2. Okay, very nice. I'm gonna put this back in here. All right, we're moving and grooving here. Are we in focus? We're kind of in focus. Yeah, there we go. Okay, did I do the 2 ones in between there? No, I didn't. I have to do the ones on top. And this is 1K. I have these right here. I think maybe a $10 Patreon. Well, thanks, James. Please do if you're able. It helps a whole lot, and it is the reason this project is still going. So any amount on the Patreon is quite helpful. And like I mentioned this before, but the rewards are updated and they're great. Like there's a lot of value there. Okay, 1, 2, 3, 4. Is that enough? 1, 2, 3, 4, 5. Okay, yeah, we'll need one more. You could probably get this, but you remind me of Elon. Yep, every now and then it shows up in the chat. Ooh, jeez. Okay, here we go. 1. And 2. And 1. 2. Okay, now we're just missing one here, so I'm going to have to open that other bag. Is this the 1K? Uh-oh, hold on. Uh-oh. 1K. Oh, they're both 1K. Okay, well this is just an extra bag then. Since I have a job now, I was thinking about dropping a 5-tier Patreon. Bluegill Brunkle, if again, you know, there's no requirement to support on Patreon. I should make sure that's clear. Like you don't have to do it, but any amount that you're willing to support BPS is certainly appreciated, and that's what I have to say. Thank you very much. And to anyone who's watching who is a Patreon, thank you very much. I know there are a couple people who are. So it means a lot, and the project would not exist right now without those people. Okay, I just need one of these. It goes right there. Okay, now we have 2 transistors to place, and then the bottom half of the board is done. Not the back side, but the bottom half. The bottom half of the back side, so a quarter of the board is done. And actually, this is probably the hardest quarter of the board. Okay, 1K. So now we have these 2 transistors. This one is the 856. Yes, there it is. Boy, DigiKey is just weird with their packaging sometimes. Okay, 1, 2, 3, 4, 5, 6. These are to help continuity detection on the board, so if something is connected to your pyro channel, these little guys will help you find that out. And that's a great thing, because if your parachutes are not connected, if your charges aren't connected, and your rocket is sitting on the pad ready to launch, you definitely want to know that. That is some critical information. Okay. Boom, done. Okay, these go in here. And we have one more. It's this one, the 46. Let me just double check. Cool. Sorry guys, I am missing the chat. I will be back in just a second. I have to finish these transistors and then I will catch up. Like the condiment, I will catch up. Ooh, 2 out of 10 joke. Boot off the stage. 1, 2, 3, 4, 5, 6. There they are. Okay, one goes here. One goes here. goes here. Okay, and then 2 more left. And then we're done with this quarter. Dunzo. And come on, flip over, little guy. There we go. Okay, clap it up for Joey B. Very nice. Bottom quarter of the board is done. Okay, 1 second. I'll be right back. I have some acid reflux, so I have to get some Tums. Okay, much better. Alright, everybody. Welcome back. It's Joey B. Let's look at some chat. Should I follow the required voltage on the component datasheet? Oh my god, yes. Always. Always. You are asking for a disaster if you do not. I've planned out a rocket launch pick that would be 7 to 8 months away. Hopefully I can manage to pull it off. Well, good luck. I would, but I'm a broke kid. I'll do that when I get a job. No worries, Chris. There's no requirement to support on Patreon. It's just a nice thing if you're able. And if not, the best way to support BPS is just to share it around. And that doesn't cost anything. See, luckily, almost all the parts here use solder paste. When I do soldering on 50 PCBs at some point, they're all through holes. Yeah, that's hard. Tums for your tum. Yeah. Thanks for the claps, Bluegill Bronco. Nobody else clapped. It's just you and me, dude. Okay. Is everyone ready? Clap it up if you're ready. If you're ready for the top part of this board. We're making good progress here, folks. Clap it up. Everyone clap it up. Nobody's clapping. There it is. We get some claps. I am designing a rocket to fly. Cool, James. Okay, so let's put some more components on here. That's the best I can come up with right now. Oh, good claps. Good claps, everyone. Thank you very much. That's much better. Good claps. All right, so this is a 16 megahertz crystal. This is going to help the Bluetooth chip stay working correctly. So I'm going to... Oop, this is wrong tweezers. All right, so there we go. Oh, let me look at the signal board. I can never remember how I have this set up. I think it doesn't actually matter which direction it is. I think they're basically bidirectional. So this crystal goes right here, like that. Same with this. And same with this. Okay. And that's it. Okay, so now we have to do the... let's do the stabilizing capacitors. And those should be... they're either 15 or 20 picofarad. I can't remember what they are. I think, looks like they are 15. And they're going on either side. 1.5, 1.2, 10, hold on. Where are they? Here they are. You've used all my claps for the day. You will be charged extra for each clap, or you can purchase the clap pack. I'm interested in purchasing the clap pack. There's going to be more clapping during this stream. Can you give me the rates on the clap pack, please? All right, 1, 2, 3, 4, 5, 6. Little 15 picofarad capacitors. Little tiny guys. One goes there. One goes there. Perfect. Perforated. I'm losing my mind. Okay. What else can I talk about on this live stream here? We gotta think of some other subjects. I can talk about I can talk about rockets to a certain extent, but all right, hold on. Can we do another Joey B. Life advice column? I like these. No one else seems to like the Joey B. Life advice, but I have fun doing it. How do you know what quartz crystal to use? Usually I just go by the data sheet. A lot of good data sheets, like I found, will help you draw the schematic around their part. So like the Bluetooth chip I use gives a couple of different examples of how to like set up all of the wiring, and that just really helps if you don't know what you're doing. Yeah. Okay, let's put some more components on here. All right, so this one here is 22K. Oh, that's a weird one. 10K. Oh, I'm missing that one. Okay, so the 10K, is there anything else that's 10K? I don't think there is. I think this is 0.1 UF. That's 10 UF. All right, yeah. Here we go. We'll do the 10K resistor. 82, 150, 22, 1M, 39, 10K. All the way at the bottom. All right, hold on. I've missed some questions here. 1 second. Let me start placing these. 1, 2, 3. This is why it's better to do them all at once if possible, because it's like kind of annoying to just do 3 at a time. Here we go. 1, 2. Come on, little buddy, get off the tweezers. And 3. Got him. Nice. And then we need a 22K resistor too. All right. More TVC, says Zach Brown. Sounds like we might talk about that. We could talk about the Nike Smoke for sure. Cool rocket. Great looking rocket. Love that they have the one fin that's a different color. Love that. And it is literally, it was literally in like the super early days of the Nike Smoke rocket. So it's the Nike booster with, oh my god, is it just the Nike booster? I don't think there's an upper stage on the Nike Smoke. Because there's all sorts of variants of the Nike missile. And the Nike is really just like Nike Smoke. Yeah, it's just the booster. So like you can have a look up like Nike Ajax. The Ajax is the upper stage. So the Nike is just this super like venerable sounding rocket booster. And the way they do this, the Nike was used to track. The Nike Smoke at least was used to track upper altitude winds. So they would set it up to like track the wind shear, and you can do that by just having smoke pour out of the nose cone as the rocket goes up, so that you can then track how far each bit of smoke goes. And if you're downrange far enough, you can get a really good estimate on altitude by doing, I don't know what the name of all this math is called, but you can do pretty accurate altitude estimates based on distance and angle. Okay, that's the Nike Smoke. Were you invited to go on the Dear Moon project? Definitely not. Can you talk TVC? I need some specifics on TVC. Like, what would you like to hear about it? Jared comes in with all of the charges for the clap. Jared, you just send me the invoice, man. Are you going to do liquid fuel rockets? And if so, how? I won't. Well, we might outsource some liquid fuel stuff, though. I got the BT60 Estes Nike Smoke, and I put the cover of the kit on my wall. Nice! My buddy Dan Dan runs an account called the Rocket Noob, and he did his level 1 certification with the Nike Smoke model. Okay, let's find the 22K. Here it is. Okay, we just need 3 of these. It's not a whole lot of them. Ooh, 1, 2, 3. It's a good idea to get some extra components because sometimes they like flip all over the place and you lose them. Okay. Come on, buddy. Get in the tweezers. Here we go. Okay, right there. And right there. It may not look like it. We're actually almost done with the top part too. There are not that many there. It's like a little deceptive. Okay, so 22 is done. Joe, have you ever considered... Chase, you doing a meme on me right now, buddy? You gonna finish the question? I'll put you down for the Big Papa pack. Does everyone want to hear this? Does everyone want to hear what Siri calls me? In the chat, write... I don't know. Somehow indicate that you would like me to ask Siri something in the chat. What did you and Everyday Astronaut do? I was part of his series, Spacing Out with the Everyday Astronaut. I was in the video where he talks about landing rockets, and we brought the Falcon Heavy into a studio and just like chatted about it. Any plans for a BFR model? Definitely. The BFR, especially like the new design of the BFS, lends itself super well to basically having a TVC controlled boost stage, and then signal in the boost stage ignites an upper stage like finned ITS or BFS basically. So the spaceship with the fins just like will fly passively. It would be a super simple model to build, and I would love to do it. Siri called me BPS.boom. Hey Siri, what's my name?
You're Joe, but you asked me to call you Big Papa.
There you go. That's like my favorite thing. Okay, here we go. 3.3. Oh, this is really tedious. 150. 3. They're all different. Oh. Okay, 3.3 NF. Which is actually 3300 UF because... Oh, no, is it? I don't think it is. Okay, this one is 39 ohm. Should we do those first? 3.3 NF. That's what we're going to go for first. PF. 3300 PF. Yeah, this is it. It's 3300 PF. Big Papa. I'm so excited to see what you do after Heavy, and did you get Stage 2 to work yet? I have not gotten Stage 2 to work yet. That is going to be a tricky problem to solve. There's no way around it. It's just going to be very tricky to get it to work. How have you liked all the publicity? It's not that much. Like, this isn't like super popular. Your boy is still yeah, I don't know. It's fine. It's not a... Alright, whatever. Okay, is there a way I can share a Fusion 360 file with y'all? I don't know if there is. So we've disabled links in the chat because sometimes it gets a little out of control. You can tweet it at me if you just want me to see it. Okay, hold on. Or like tweet a screenshot at me. That would work. And boom, there we go. Okay, so that's done. Next up, let's do these 5.6 and 8.2. Actually triggered Seared on my phone too. bit surprised that worked. Yeah, David, usually Siri is like pretty good at recognizing the voice, but I don't know. Hey Siri, do you recognize my voice? Hey Siri, do you recognize my voice?
I'm sorry. I'm afraid I don't have an answer to that.
Oof. All right. Well, she won't tell me. Okay, this is 5.6 right here. And right here. And right here. Ask me what else I should ask Siri. Let's do that. That's a good segment. What should I ask Siri? Okay. Motherboard did a good article on you today. They did! Actually, here, let's play this game. Oh my god, it's on like the front page. Wow. Here. That's the motherboard thing. It came out really well. We did like a whole phone review. Okay. I'll tweet at you, but it's a TVC I've been working on, similar to the aluminum one some guy on Reddit made. Okay, cool. At what point is a model rocket considered a missile or dangerous? I really want to know. There is no hard line on that, Chris, and there is intentionally no hard line on it. So, like, let's say you're a government and you want to prevent your citizens from building missiles. Like, that's a reasonable thing that you don't want your citizens to do. So you write, the way you do that most effectively is by writing really vague regulations that you can enforce when you want to enforce them, and then ignore when you want to ignore them. So, like, okay, I'm actually not going to get into that much, but that's the answer. Is you write, it's a vague regulation, and really, it's a lot more about intent than it is about specifics. There's not like a really hard line. I think when you put ammunition on it too, I think when you put an explosive on a rocket, like a deliberate explosive that is meant to blow the vehicle apart, that's probably when you start getting into really hot water. Okay. This one. Oh, should we go down? Yeah, let's do this. 1.8. So 1.2, 1.5, 1.8. Your invoice has been sent. Did you actually send me an invoice? You did not send me an invoice, Jared. Not that I can tell, at least. You're not required to send me an invoice, by the way. Okay. Does Arc have a Piggy board? Yes, it does, and we built it just at the beginning of this stream. It's right here. This is how Arc gets programmed. Real talk, though, what's going on with you and Grimes? I don't want to talk about it, Chase. Okay. Here we go. There we go. 1, 2, 3. Alright, this one goes up here, I think. Wow, that's not a great thing. I should really know that before I just place things. Yeah, 1.8. And it's closer to the thing. Yeah, that's correct. Here we go. Right there. Right there. On Twitter. Oh, no auto flight termination system. I thought you said that for the Falcon Heavy, this one. No, so what I mean about an explosive... Okay, I'm actually not going to have this conversation. I think this is probably a bad idea. It's... When you know, you know. Like, it's pretty clear when the missile that you're building is intended to be a missile. That's what I'll say. There are differences. Okay, this is 1.2. Right here. Okay. All right, guys, we're cruising along here. I'm super excited. This is going really well. 1.2 and 1.5. Okay. And that goes right there. Oh man. After this we have like 3 or 4 more things to place and then we're done with the back. And then we can do the melt. Okay, here we go. 1.5. Okay. We are almost there. This one right here, it's 3.9. It's an inductor, which is cool. It inducts. Okay, that side's worked. 1, 2, 3. Buckle my shoe. I'm gonna stop using that phrase. All right, inductor goes there. And it goes there. Okay, cool. Okay, almost done. Almost done. I'm getting excited. Can we catch up on the chat here? 3 hours. Is that how long we've been streaming? I think that's probably right. Yeah, 3 hours. Good deal. That's not so bad. It's an hour per board. Don't forget to say Elon's prayer before the first boot. Can I build a guidance computer out of an Arduino Mega? James, you ask bizarre questions, man. You ask some bizarre questions. Oh, sorry, I thought you said missile guidance computer. You can. I have flown rockets with an Arduino Mega. There's not a lot of memory or processing power. There's just a ton of outputs. It's probably not an ideal computer for the task. It's probably just like over outputted. Okay, 150 on this one here. 1039. Here it is, 150. Do model rockets ever get to the height of needing a bell or nozzle? So, model rocket motors actually have nozzles on them. Like if you look at little Estes engines, the opening of the throat is shaped in like it's a conical nozzle. It's not like a De Laval nozzle. Well, it's not a how do I say this? It's not like a bell so much as a cone. But they do have nozzles. And 1, 2, 3. There we go. On the board you go, little resistor. Okay. We're getting down to the wire. 150. And I think they just go down. Yeah, 82. $39, 1, 82. Do I play Space Engineers? I don't think I have played Space Engineers. What's it about? I mean, I have a general sense that it has something to do with space and engineering, but I don't think I've played it. I don't actually play a whole lot of games. At least video games. I really like card games, though. Okay, 1, 2, and here we go, 3. Boom. Very nice. Okay, one more in this little stack here. And I think it's 39. I think it's 39 ohms is what we want. I'm gonna get this out and then double check. Measure twice, cut once. 39. One, two, three. 1, 2, 3. Okay, one more passive component and then the SD card mount. And that's an easy placement. And then we get to do the melt. Okay, this is resistor. What is the passive component up here? I think it's 10 yeah, it's 10. Oh, I'm putting resistors back in the capacitor pile. That's how you know it's time to do the melt. 1, 10. Sometimes it cuts on the edge. There we go. 1, 2, 3. These are kind of beefy capacitors. Okay. Don't clap it up yet, but we're about to clap it up. You're about to clap it up. Okay, so now we need, what do we need? This. Little SD card readers. And that's done. That's gone. And number 1. Ooh, man. There is no room to spare on this board, ladies and gentlemen. Holy Moses. Oh, it's so tightly packed. Okay. I'm going to have to be really careful not to solder those parts together. I might have to move that component. It's like not an ideal place for it. Okay, there we go. Okay, woohoo! Look at them. They're so tiny. There it is. Okay, it's time to do the melt. Are we all ready? Is everyone excited? We can clap it up now. Clap it up. Okay, James just use a nano. Yeah, Arduino nanos are good. How difficult is using radio transmitters to transmit data from a rocket to the ground station? I have no idea. BPS.space engineer server. Do I play KSP? Of course I do. I love Kerbal Space Program. Want to know something dead? Is the BPS did cord. Hey, ouch. Ouch, buddy. You're right, but ouch. That's why the Patreon got revamped, because the Discord wasn't really working. It's still there, and it might still be helpful, but we need a lot more people in it. Sandbox game that you can build spaceships in and mine resources. Oh, that's cool. So you've done these board population sessions for all the boards you've sold? Well, not for all the boards I've sold, but for all of the different variations of it, generally, yes. Like, I'll get a new board, and I'll assemble it on a live stream. I'll get a new board design in, and I'll assemble it. Lots of claps. I love it. Lots of claps. Good job, everyone. Just tweeted the TVC at me. Well, let's look. This thing is still heating up, so let's look. I'll give you some feedback. Okay. Oh, this is a really nice post from this guy Joey. Congrats from another Joe. My students love watching your videos, especially since you don't post the success. You don't just post the successful launches. Thanks. I gotta hold on. Okay. Sorry. No tweeting and streaming. Jared, thank you for the invoice. Thank you very much. I don't know. Did you tweet at BPS.space? Let me look on the different account. I don't see any TBC thing. It might be BPS.space. That might be what it is. Here she blows, TBC. Let's look. Okay, it's loading. It's taking a while to load. I'm gonna look at the chat for a minute. Did I reach 40? You have more tea. I did not reach 40. I wish I did, but couldn't quite get there. How often do I go live? Because this is really, really fun. Not that often. I would like to do live stuff more, but like yeah, not that often. Sometimes. Well, Joe, great stream as always. I have to go to work to get that Patreon money. Thanks, Bluegill Bronco. Again, it's not required, but it is appreciated if you do end up supporting. Sounds like you're gonna head out, but thanks for joining us. Will there be a model of the BFS BFR? Yes, there will. Do a live stream if you playing Kerbal. I could do that. I cannot see the TBC thing that you sent. I'm so sorry. It just shows up as a blank thing. Can you just send me a screenshot, Zach? If you send me a screenshot, that'll work. Or it should work at least. Hey, also, if you want to follow if anyone wants to follow BPS on Twitter, we're at 995 followers. Someone's got to push it over. Push it over to 1,000. Okay, it's back to work though. Time to get back to work. Actually, it might be time for tea. We'll do tea after we do the melt. Okay. I need everyone to start chanting in the chat. Can we do this? I need a chant to begin. And the chant goes like this. Do the melt. Do the melt. Like that, okay? I need everyone's cooperation on this. Alright, that's a good frame. That's a good shot of the... Do the melt! Do the melt! Yes! Okay. Are we ready? Is everyone ready? Do you want the melt? So the first thing, I think we're just gonna heat up the bottom of the board first. And this is gonna kind of be off camera. But I'm just gonna heat up the back side of it, or really what is the front side, but the back side for this. Because I kind of want an even heating through the fiberglass before we get started here. Okay, and that should probably be good. You don't really need a lot of that, but it's just a little helpful. Okay, are we all ready? We're gonna do the melt. Here we go. It's starting. Ooh, there it goes! All at once. Oh, I love that. Now I'm just going to make sure these are all in the right place. But they all look pretty good to me, so. Yeah, these look good to me. Some of them are not totally. Oh no, that's connected. Yeah, I think we got them all. Wow, good job doing the melt, everyone. Okay, we're gonna set this aside. This is so tiny. It's like amazing how small this is. I love this so much. Okay, time to do 2 more melts. We're gonna heat the bottom side first, just like the last one. We don't need to chant the do the melt anymore. You can chant do the melt if you want. Your voice sounds just like Grant from Mythbusters. I'll have to look up who Grant is. I actually don't remember who Grant is off the top of my head. I hope that's a good thing. Okay. Mission accomplished. The chant worked. Do the melt. I sent you a link on Twitter when you have time. Cool. Thank you. I will check it out. About to do the melt again. Oh, sorry, it's out of frame. There we go. All right, here comes the melt. Ooh, got a little burn there. Okay, so that looks good. These all look pretty good. Yeah, I think this is another good application here. I don't see anything disconnected. I don't see any bridge leads. I think this is a good one. I'm just going to cool it off a little bit and then set it down. And one more melty boy. So first, once again, and heat at the backside. I hit you up with the pic on Twitter, by the way. Zach, we will check it out right after we do the melt here. Okay. Do the melt. Do the melt. Do the melt. Do the melt. Wait, get it in frame. Then do the melt. Oh, there it goes. Woo, they all like wiggle. Okay, this one is not as good. We got some problems here. Okay, this might be okay now. Okay, that's good. All right. Very nice. My tea is cold, but it is done. How do I do the booster sep on the Falcon Heavy? It's passive separation, so the center core is held up by the side boosters. If you lift the rocket up by the side boosters, it will stay intact. If you lift it up by the center core, it will fall apart. It's totally passive. Very nice. I love this. They're so tiny. Okay, good work, everyone. Oh, that's a little There, I'll zoom out a little bit more and squish them together. Okay, apparently Zach sent me a thing on Twitter, so let's look. Ooh, okay, what do you got going here, buddy? So, oh, but you don't have any mechanic. Yeah, that will work for gimbling for sure. But you don't have any mechanics to like actually make it happen yet. This is just the mount that it can rotate in. That looks fine to me. Like your thrust structure looks fine. As long as if that's actually made out of aluminum, it'll take a ton of force, which is great. Yeah, that looks good to me. Okay, cool. That's not a real tag. That's not a real teed. It's Big Papa juice. Hey Siri, what kind of juice do I drink?
Okay, I found something on the web for what kind of juice do I drink. Take a look.
Should we look? No alcohol drinks for people with diabetes. That's the kind of drink I drink. According to Siri. Okay. Here's what we're gonna do. Everyone, you see these boards? These are about 75% done. The other 75% happens right here. But before we do that, oh my gosh, it's only like 8:32. This is great. We have plenty of time. Before we do that, I have to go to the bathroom. I have to get more tea. And you have to go to the link that is about to show up on the screen. You have to. By just staying here, you have a passive agreement with me. It's a blood oath covenant with me right now that you have to go to this link. Okay? That's the deal. I'm deadly serious. If you don't, you're gonna have bad luck for 20 years. Okay. I'll see you back in about 2 minutes. And that's all I have to say. Don't go away. Hello again, everybody. It's me, Joey B, back with another slammin' live stream. So, here we go. Right now, we're about to have some Country Peach Passion herbal tea. That is what it's called. It's by Celestial Seasonings, and here we go. There's no tea bag in this one. It's just like the tea bag's just like sitting in the bottom. There's no like little string. Very nice. Okay, cheers everyone, except not, because this is going to be hot for about 5 minutes. Okay, and time to move back to the workbench. Here we go. Hello? Okay, yeah, the mic is still working. Just making sure the mic is working. So, this is going to go over here. I'm going to let that sit. I'm going to let that stew. How did everyone like the Barnard bathroom review? You were all obligated to go, so I assume all 28 of you visited the link. If you did not, boy, I just wouldn't want to be you if you didn't make good on that oath. I just think it would be really bad for you and your family. Okay, too far, buddy. So Chase asks, how much is ARC expected to be? I'm trying to hit a $99 price point. And I think that's pretty competitive for what ARC does. So that's what it is. It's not an official price yet, but that's where I'm trying to aim for. Jim, yeah, it's 75% done, and we're gonna do the other 75% now. The whole 150. Great link. 4 hours. Yeah, 4 hours streaming. That's a big deal. It's art so great. Such a great site about restaurant food. Okay, everybody, it's time to do the front side of the board. So, we have, should we recap what there is? So, we have 8 passive components here. We have some bigger things. We have voltage regulator, power switch. It's a crowded board. Like, that much is definitely for sure. It's super crowded. But, let's get into it. Hold on one sec. Let me make another plug here. If you are not already following at BPS_space on Twitter, please, 3 of you need to follow it for us to reach 1,000 followers. Smash that like button. Can we get to 10,000 followers in one night? Sorry, I'm doing a little bit of a meme. All right, here we go. So first thing we need to do is put the solder paste on again. So this is a different solder stencil. Right now, this is for specifically the front of the board. We have these pieces of tape that we need to use. We're going to put these on ARC, like that. And where's the other piece of tape? Like that, and like that. Okay, here we go. So the board goes onto the stencil. And that's it. It's actually a pretty good lineup there. And now before we do anything, we actually need some solder paste on our little spatula here. So let's do that. Do the squeeze. There we go. Here's some solder paste. Okay, and begin. Commence. I'm not sure this is enough solder paste. That does look pretty good though. Okay, so, oh my gosh. Take this off. Actually, I'm gonna do one of these. And off it comes. Ooh, perfect. Yes. Good work, everyone. Now, just like last time, we have to wipe the top of it down, or just the bottom of it, really. Doesn't leave any residue. Okay. Then, this one goes on. This is going to be 1,000 times easier once these get assembled by a machine. But especially with new designs, it's good to just kind of do it yourself. To get familiar with the board and how assembly works. We're going to need more solder paste. Okay, that is good. I'm missing some questions here. Okay, this looks great. This is coming out really well. And we have one more to do. But we need a little bit more solder paste for this one. That's probably enough. Line it up, tape it down, and go at solder paste. Maybe that wasn't enough. This is not really working. I think it can make it. I can make it last. Here we go. That's it. Cool. Bingo, bango, bongo. Perfect. These come off. They go here. This gets a little wipe down. And, oh, and we want to wipe down the top of it too. Basically, we want to get all of that solder paste off of there, because if we ever use this again, it's going to mess things up to have like residual dried up solder paste on it. And that is why you want to wipe it down. And that looks pretty good to me. I'm going to give this a quick rinse. 1 second. Quick rinse for the solder stencil. Looking much better now. Nice and clean. Spick and span. There. Okay. Hello again, everyone. So, I've missed some chat. Let's catch up here. Brian says that he missed the answer to his question. Brian, could you just ask your question again? Because I'm not sure what yours was. I'm scrolling up here. I think I missed your question. Anyway, just ask again. Can I get 46 more followers to have double my following? Is this your only electronic project, or have you done other projects? Oh, a ton others. Yeah, there's a bunch of live streams on the YouTube channel that show other projects kind of like this and similar. Yeah, a bunch of others. Okay, hold on. Okay, this looks good. Cap off the solder paste. And what all things could you do with ARC? Well, it'll deploy your parachutes. It will sense continuity on each channel to make sure your parachutes are going to deploy, which is pretty important. So, like, it's a little bit like insurance. It will log a ton of data for you. It will show you the orientation of your rocket. It will show you the acceleration of your rocket. It will show you how high it went. You can configure it all with your phone. You can static fire your rocket. It's a pretty solid brain of your rocket. And then anything else that most dual deploy computers do, this will do too, but with a way friendlier interface. Okay, folks, so let's start with the small passive components. That's the way I think we should do this here. going to put this around so I don't block it with my hat again. And if this is how it looks now, let's just make sure we're in focus, which we kind of are. Okay, that looks pretty good. So let's start at the bottom. We're going to start with the passive components that are kind of around this section. And let me just adjust this here. Top, top, top. Boom. And all right, so let's start here. We've got 2, okay, 1 and 1, 22, 22. Okay, these first 4 are very easy. These are just 1 UF up top, 22 on the bottom. Man, I can never get this to work really well. There we go. 1, 3, 4, 5, 6. Okay, so 1, 2, 3. It's a very exciting time. 4. It's an exhilarating live stream. Tons of ups and downs. 5. And coming in for number 6. What brand and model of hot air soldering station are you using? Oh, I'm sorry, Brian. I did see this and I did not answer it. Okay, I have it taped over. I don't know why. It's a Zenny hot. It's not good. Like, I feel like if you have any interest in not burning your house down, I have heard of these catching on fire before, so I keep mine constantly unplugged. Hold on, let me just find the right capacitor here. 1 point something. Uh-oh. Do I not have 22 picofarad capacitors? I think I should. 1K. These are resistors. Oh no, I hope I didn't leave them out of my cart. Resistor, resistor. Inductor, inductor, inductor. Uh-oh, folks. Did Joey B goof? I think I may have done the goof. Okay, resistor. This is my order here. Resistor, okay, 1.2, 1.8, 15. No, I have it in here. Okay. There should be 22 picofarad capacitors somewhere. Hang tight, everybody. We're going to figure this out. They are not here. They are not here. Crystal, nope, not there. 33. Oh! It's because they're in the weird bag. That's why. Alright, oh! Insurance fraud, here I come. Yeah, so here's how sketchy this here's how sketchy this soldering station is, Brian. It's a soldering hot air station. Do we all know how to spell soldering? Right? S-O-L-D-E-R I-N-G. Soldering. Even if that's not right, it's pretty close. And this is called soldering hot air. The name of the product is soldering hot air. S-O-L-E-D-I-N-G hot air. Soldering. Like they didn't get the spelling right on the product name, and they printed it on it. It does work, and I have not had problems with it. I've had it for about 1.5 years. but I'm not sure. I'm not sure it's a super safe product, is what I can tell you. Buyer beware. It was really cheap though. It was like $60, I think. Okay, almost done with these little capacitors here. These are some stabilizing capacitors for the crystal, which we are about to put on. It does work. I have not had problems with it. Translation is not the easiest. True. Alright, so we need the, is it the 16 megahertz crystal? No, it must be the 32. Uh-oh. But where is that? It's not here. Oh dear, everybody. Where do you think it is? Did I not order it? Oh my god, no, it's right here. I'm just really bad at finding these things. Okay, here we go. 1, 2, 3. There they go. I'm gonna try to get the text to show up upright on these. 1, 2, and 3. Very nice. Ooh, this is a really good looking PCB. Let us know if you needed a chance. Okay, hold on. Are the capacitors used for keeping current stable? Yeah, I think it's more about voltage. Suppose it could be current. Well, I think it's more about voltage. I don't know. They're for stability though. That's what it is. It's to help keep things in line, reduce spikes. Okay, now we need a little diode, which is right here. Okay. One, two, three diodes. 1, 2, 3. And there it is. Lovely. Oh, it's kind of big. That's okay. And there it is. Okay. Looking good, everybody. What's next? Looks like we have a 3.3 volt regulator next. Our capacitor. Oh, let us know if we need to chant "Find the part, find the part." You can do it. Disarm you with A. Thank you. Cool username. How do you know when to use a capacitor? Generally, the rule of thumb is like, the more the better. Yeah, the more. Usually they'll recommend it in a data sheet too, and then there are just some rules of thumbs, like if you have a sensitive sensor, like a delicate sensor, you put a couple of capacitors around its power supply. You can't go super wrong. You can't go like super wrong with it though. One, two, three. 1, 2, 3, and 1, 2, 3. Whoa. There is no extra space here, folks. You have to bridges. Good one, Jared. BPS. Okay, so these are done. We have 4 more passive components to put on here. And they are, okay, 100, 100. Ooh, they're both a... What are they both doing? Oh, okay, I got it. Yeah, I know what those are. okay then. Not what I thought, but sure. Okay, here we go. We need 2 per board, so we need 6 total. 1, 2, 3, 4, 5, 6. Ooh, it's getting crowded. That is for sure. Get off the thing. There we go. Okay, there and there. Got him. Okay. This one's a little off. All right. This needs a bag. This needs a bag pretty badly. Let's use this. And we'll just cover up this stuff. And call this what it is, which is a 100K. All right, how we all doing? Still got 28 people viewing. Why only 3? Because they are still... Sorry, the question is, why are there only 3 of the ARC board right now? Because they are a development board. This is the first version that I've actually made. And so there's a really high chance that I got some stuff wrong. Because it's a totally brand new design. 10 and 4. And so, you know, you only make 3 first. And then you make sure they work, and then you can make 1 billion. Roughly 1 billion. Okay, 10, 3, 1, 2, and uh-oh, wait, I put that in the wrong place. 3. There. That's 10. And 1 goes on the other side. 1, 2, 3. There we go. Okay, 1, 2, 3. Okay, one more component on the bottom. That's the switch. And that is here. Where's the switch? There it is. Yeah. Okay. And it's gone. That's trash. I have to be careful not to burn the switch when I do this. Okay, the switch goes there. 1, 2, and 3. Oh my god, you know what I didn't do? I didn't put any indication as to which position is on or off on the switch. This is why you only make 3 first, because like this is a design error. It's a user experience error. Okay. What next? All of these sensors. That's what next. We need some tea though. What would the PCB view look like if you rotated it 180 degrees? Well, then it would be upside down for me. I suppose we could do that. I don't really mind. It doesn't matter to me. As long as everything is in the right orientation, that's what matters. Alright, how does that look? Yeah, that's what ARC looks like now. If it works, it's on. Hey, Alan, what's up? It's great to see you here. All right, let's start with the processor. That's the biggest one here. All right, here we go. The venerable and reliable ATSAM D21G processor. I'm gonna toss all of this. We don't need it. I'm gonna write the label on here. Proc. Okay, that's all good. One, two, three. All right, that goes there. To tilt these over. All right. One processor. Two processor. Be very careful to make sure it's in the right spot. See, this is a little tilted. There. That's good. And, oh my gosh. Three processor. Ooh, it's getting a little crowded. All right, what next? How about an IMU? How about an inertial measurement unit? That sounds good to me. Oh, I do not understand how DigiKey decides to structure all their bags. All right, IMU, we're just gonna keep the trash. And there are only 3 of them here. Oh, let me make sure I know where the orientation dot is. It's in the bottom right. Oh, because this is the same orientation as signal. This is correct. So, yes, okay, got it. Because I was really specific about making sure the orientation of the sensor was like congruent with the existing software. Okay, here we go. One IMU. And 2. And 3. Ooh, looking good, everybody. It's silent in the chat. Tell some jokes. Who knows a good joke? Let's tell some jokes in the chat. I can start it off. Where does the astronaut go to get a beer? The space bar. No, there's something better. There's something better about that. Where does the astronaut who likes to type go to get a beer? The space bar. No. See, this is why I need everyone else to tell jokes, because this is not going to work if I'm just the only one telling jokes. Okay, next up, let's do the barometer. Loud noises. Hello? Okay. The audio is fine. You made me worry about the audio for a second. Stop with the memes on the Discord. All right. So let's find out which way the barometer is oriented. It's near the bottom right processor. Yeah, that's correct. Okay, so this is the barometer. This is the pressure sensor. Right there. There's one right there. And there's one right there. Ooh. Every component that goes on, it gets like a little more fun. This is done. We don't need that. We can keep it though. How about the flash next? Okay, these go in the trash. That goes over there. This goes in the trash. This gets unplugged. There they go, my little flash guys. You can get No Man's... You advertising games here, Jared? Okay. This goes right there. There we go. Come on, get seated there. Okay, that's pretty good. Next, LED, I think. Here we go. What kind of music do I listen to? All kinds of stuff, man. Sometimes it depends on what I'm doing. So, whoa! Why did I order so many LEDs? I have no idea why I ordered so many. I guess it was a cheaper deal or something. What kind of music do I listen to? I listen to all kinds of things. And so sometimes it's like singer-songwriter stuff, if I just want to listen to a nice song. Sometimes if I'm working, like if I'm coding, it has to be like non-lyrical, like progressive trance music or like house music or something. Because, oh man, where's the corner of this? It has to be something like that because it's just like how it's like a hack for my brain. It makes me focus. Okay, top right is where that goes. And that's right there. Oh, but it's upside down, so it goes right. Yeah, this is correct. There, so this is the LED. It's gonna make lots of blinks. Okay. And then we need the Bluetooth chip, and then it's time to do the melt. Alright, am I waking anybody up? We need another bag here because these don't have one. Hold on. Do the awoken. Don't get too sleepy here. LEDRGB. Okay. That goes there. This is the Bluetooth chip. It's the last step. Oh, it comes with its own bag. Excellent. Go. This goes in the garbage. Ooh, Oh, hey, Eric. What's up, dude? I know, for whatever reason, you only exist on Facebook in my mind. I'm sure you exist in real life. You only exist in the Facebook SpaceX group and the PCB group. Or PCB Facebook. That's what it is. Okay, here we go. And let me just confirm where the dot on this needs to be. I think it's on the bottom. Yes, that's correct. Same as on signal. Okay, one Bluetooth chip. 2. Get ready. This is the last one. This is the last surface mount component. Are we ready? Boom. Got him. Okay. I love this. This looks so good. It's time to do the melt. I have to quiet down. I have neighbors. It's Friday night, though. I can be loud. That's fine. That's acceptable. Okay. Where's my little guy? Here he is. It's melting time. My body is ready. I am FB level smart. I lurk on NSF there. Oh, cool. All right, do the melt. Tell the neighbors to vape off. It's melting time. Okay. Oh my God, it's so tiny. Ah, it's amazing. Okay, so first we're gonna do the same thing as before. I'm gonna need, listen up everybody. When it's time to actually do the melt, I'm gonna need a really big do the melt, like big melt energy, okay? That's gonna be required. We're not doing the melt yet though, we're prepping for doing the melt. I just want everyone to be ready. Get your clap emojis ready. Get your like stomp emojis ready. Get any loud noise or explosion emojis ready. Because it's almost time. Okay. Are we ready? Someone start it off. Start it off. Start the chant. Spam the chat with do the melt. Do it. Do the melt. Do the melt. Do the adjust the camera. And then do this first so that we can do the melt and everyone can see. Do. Oh my gosh, come on. Do the melt. Do the melt. Here it is. Do the melt! Oh, this moved. These all moved. Oh my god, hold on. This is a disaster. The melt was too strong. There we go. That's better. We're just doing a little slidey boy here. Okay, can everyone see? Do the melt. Do the melt. It's doing it! Oh, the prize. Do the melt. Okay, I think we've done the melt, folks. Okay. This is the first board that theoretically should work. YouTube won't let me sell tuna melt. Tuna melt. Tuna melts are great. What an underestimated food. Okay, so this is it, folks. This is the first arc board. Ooh. Oh, I love it. Oh man, this is amazing. What a great feeling. Okay, I'm gonna put this to the side and do a second melt. This melt will be upright. Like that. And it shouldn't fall off like the other one did. Okay, so first we need to heat it up, prep for the melt. Very important part of the melt. Peach passion. Peach passion tea. Okay, it's ready. It am become ready. Okay, are we all ready for this? I need 30 minutes and a drink, says Jim. Me too, buddy. Me too, dude. Okay, here we go. Oh, wow, it's already happening. Ooh, yes. It hath begun. The melt commence. Put a break. Let it sort of even out here. Let's do this. Is this good? We all see like lots of stuff now. That's unnecessary. I think this was a successful melt. I have to say. There's a lot of tuna on this thing because it's a successful melt. Got him. Okay. This is looking very nice. Oh, it's so light too. There's nothing here. Just want to make sure it doesn't get bad. Okay. And round 3. Fight. The only thing it needs is more melting and more boosters. Got him. We still have 28 people watching. That surprises me. Okay, that's a good amount of heat. I'm gonna bring it back into the frame here. Make sure it all looks nice and good. Let's do this. Can we do an ultra close-up? We're gonna do an ultra close-up on this section here. We're gonna get a close-up melt. Is everyone ready? All right, here we go. I'm gonna start at the top just a little bit. It's melting. It's doing it. Uh-oh. One of them went off the path. There, that's better. There. Very nice. And then we just need to make sure the top has the melt as well. Okay, this has a bridged lead. Oh boy, I'm ruining this. Now this is a bridged lead. Okay, now this looks pretty much good. All right. That's it, boys and gals. How long was that? How do we do? 4 hours and 19 minutes. Not so bad. Not the most best, but not so bad, especially for a first revision of the board. So, what are we thinking, folks? What are we thinking? I think it's only 9:30. Okay, is anyone down to do like one more hour? I think one more hour max, because we should try to boot this up. We should try to see if it actually works. You know, there's a chance it doesn't, but in the chat, say yes or no. Yes means one more hour stream, I guess at least, so that we can boot it up. And no means please just get the hell out of here and stop streaming. We've got yes, yes, yes. We've got a yay. That doesn't count, Jared. A yes, a yes. Okay, we've got lots of yeses. So here's what I'm thinking, everyone. Rice Farmer has 77% battery left. You should plug in. I want to see blinking lights. Yeet! What does yeet mean? I don't even know what yeet means. Am I old? Does that mean I'm old? All right. Party mode or riot? I agree, Mr. Steven. So here's how we're going to play this game. The game is called We Need One More Intermission, because I need to go to the bathroom. Oops, sorry. Need one more intermission. Then I'm going to come back, and we're going to make this thing blink, okay? That's the name of the game. And then I'm probably going to bed. Okay. I'll be back in 2 minutes. And if you leave, I will well, you don't even want to know what happens if you leave. It's so bad, like I can't even say it. So, just don't leave. I'll see you soon. Hello again, everyone. It's me, Joey B. It's your boy. And today we're going to be programming these arc boards. Now, I want to give you a bit of a preface here. Where's my screwdriver? So, the chance that this actually works is very low. I just want to set some expectations. The chances that this works on the first try are hold on, is this loud? It feels like this is a little bit loud. Okay, that's better. The chances that this actually works are very, very, very low. So I'm at my desk. There's a lot of noise in the sound. Is that intentional? Hold on 1 second here. So this I'm going to turn all the way down. Hello? This should be a little bit better. Yeah. Okay, so RIP old printer. Sent you a link on Twitter. You should check out for help for the second stage. Okay, I will. He's lost it. There's a lot of noise. Background better. So should we switch to the webcam keyboard view? I think we should. I'm also going to close out of this and try to put OBS just in the background here. And we're going to open up Arduino 2. I will switch the display in just a minute, and then we'll have a full view of what's going on in Joey B's life. But this should be good. I have a good feeling about it. I have a good feeling about it. I don't have a wonderful feeling about it, but it's a good one. Oh my god, see, this is not even aligned. Oh man. Ooh. Okay. All right. So here we go. Let me make a new file here called arc LEDs arc. Okay. Now we have to change a few things. Hold on 1 second. I promise we are almost there. I need a new window in Chrome. Probably should have come back from the intermission like a minute earlier. What's going on? What's going on, everyone? What are we all doing right now? I just need to find out the outputs for the LEDs. So the green LED is on pin. Okay, what's this one? 10. Oh gosh, I hate the Google Images restructuring. Pin. Yeah, okay. PA. Got it. Okay, so the green is on 1. True. The B is on 14. 14 is... Where's 14? Oh, hold on. It's on 4. The green... wait, what is it? The blue is on 4. And the red is on 16, which is 11. Okay, very nice. And then we're just going to get rid of this stuff. I'm gonna get rid of this stuff. Okay, I'm gonna turn on the other side of the screen now so you can see what's going on. And there we go. Hello everyone, it's me, Joey B. Okay, so this is a sketch that's going to be used to test the LEDs on this board. Let me just get rid of the things there. I'm gonna compile that. And while that's happening, if you can see down here, what's going on here, this is my desk. This is like right under the screen. The camera's not very good, but that doesn't matter so much. So, this is an Atmel ICE. This is a programmer. Now, this is the Piggy board for Signal, which we don't need to be using. And so what we're going to do instead is replace all of the wires going into the Signal Piggy board, or replace all of the wires going there and put them into the ARC board. So where's this one? This one goes here. I need all of y'all to cross your fingers just like so hard right now. Okay, CL. That's this one. It's a very sketchy situation we have going here. CL goes here. Oh no, we don't even have screw. Okay, it'll be fine. It'll be fine. Okay. IO goes in here. Okay, that's all good. We need some power. How about ground? Thank you, Piggy board, for all that you do. Okay, that's ground. Oh, should we just do it here with the 3.3 volts? I suppose it doesn't really matter, but... Okay, ground and 3.3 volts. And that means the signal Piggy board is officially done with its task. At least for now. Okay. All right, now it's actually not done with this task because we need to take these. Can we just use different screws? Okay, here's what we're going to do. These are going to come off. It's going to come off here. And there. Okay. Now, 1 second. I need 4 screws. 1, 2, 3, 4. And these 4 screws are going to help align the ARC board onto the Piggy board. So the screw goes there. I hope this is interesting. I'm not sure if it is. Okay, there's one. We get the chat open here. No magic smoke, no magic smoke. Okay, this goes here. How many viewers do we have? Oh, still 28. That's pretty good. Okay. That goes there. This one goes here. This is such a tiny little board. Okay, this goes here. And then one more screw in here. Where's that extra? There it is. The more screws and things like stick out of the Piggy board, the more it looks like a medieval torture device. Okay, the Piggy board is ready. Now, the ARC boards. It is time. So, step 1, we're going to plug this in. The MLICE is going to turn on. We're going to get a light from it. We have a red light. I don't know if you can see that there. Step 2, we're going to plug in the Arduino Uno, which is the power source for this whole procedure. I really don't think this is going to work. Okay, green light, because it sees that there is power on there. Step 3, deep breath, breathe in, breathe out. It's going to be fine. We're going to put the ARC board on the Piggy board. Okay, it is on. Now, we're going to go up here. I'm going to make sure nothing's shorting out. Nothing feels like it's shorting out. I'm going to go down here. I'm going to push it nice and far down, and I'm going to say burn bootloader. Ready? Shutdown command invoked. It worked. It worked. It burned the bootloader. Okay. So now I'm going to unplug it. I'm going to pull away power. Okay. It worked. So I'm going to put this back to the regular M0, not the special sauce that has to go for signal and arc. Okay. Everyone, once again, please pray with me. Wait, hey Chase, are you in the chat? Can we get an Elon prayer here? Does everyone remember the Elon prayer? Chase, please help me find the Elon prayer. We do need to do one recitation toward God Emperor Musk here. Elon's prayer. The Elon's prayer? Okay, can we just read this? I think Chase made it up. We're just gonna do this one. I'm gonna make this really big, and we're all going to recite it at once. I don't care if you're in a public space and oh my God, what has happened? Hold on. What have I done? Okay, there we go. Old Muskie. So, literally no one has ever called me that. The Elon's prayer. Can we all see it? Can we all read it? It's a little cut off at the bottom there. So that's probably good. Ready? I'm going to take a sip of tea. Put your hands together, please. And pray with me. Our Elon, who art in dragon, hallowed be thy rockets. Thy ITS come... BFR now. It's BFR now. Thy will sure launch on LC-39A as is on Mars. Give us this day our daily launch, and forgive us our Jason 3, as we forgive others at a lie. And lead us not into Russian engines, but deliver us from the expendables. For thine is the launch pad, the shock diamonds, forever and ever, until the heat death of the universe. A Martian. Okay. It's time. So here's how we're going to do this. I'm going to take the micro USB out of here. I'm going to plug it into the Piggy board. So now we are talking directly with the ARC flight computer. We're not talking through the debugger or programmer. I'm going to plug it in. I'm going to press it down. And we're just going to hold our breath. Oh, I don't think it's there. I don't think it sees it. Nothing's hot. It did burn the bootloader, though. Like, it would have given me an error if that had not worked. So, there is still hope. Oh, there it is. Everyone be very quiet. Stay very still. Oh! Oh my God, it works. My neighbors are stomping around upstairs. The prayer has done us good. Thank you, O Elon. Thank you, old Muskie. Papa bless. Thank you for the memes. This is amazing. This is the best thing I've ever seen in my entire life. Truly. Here's what I'm going to do. I'm going to take this off for a second. We need 2 more of these nuts to keep it on, because right now there's like no battery terminals. Hold on. Is that amazing or what? On the first try. That is a brand new design. On the first try. It's ya boy Joey B. Okay, wonder if we should try to see if any of the sensors are there. probably not. Anyway, look at that. So it's working. We built a working ARC computer. It's like hooked up to all of the like garbage that it needs to get programmed, but that is the best thing I've ever seen. Oh, that's so cool. Okay, well, does anyone have any questions? I think that might be it for tonight. I'm so thrilled that this just works. There's a ton of flight software that still needs to be written. We still need to test out all the Bluetooth stuff, like the sensors need to connect and be stable. What else could go wrong? Like the Bluetooth antenna is a different design this time. But this is huge. I'm like, I can't believe it worked. All right. Well, I think that's it for me then. I'm gonna go to bed because I'm so tired. How long was this? Okay, this was a 4 hour and 47 minute live stream. That's amazing. Thank you all so much for joining me today. This has been awesome. This has been the least troublesome PCB build yet. Like, no errors. Yeah, and I thought it wouldn't work, and it did. So, thank you all for joining me so much, and have a great night. Oh, wait, I didn't transition yet. Oh my god. Have a great night.